Today, let's quickly start off with pandas to talk about. So, let me move forward with the things. So, before I go forward and formally introduce the ideation behind that, right? So, could any of us would help me out with what is pandas and why is it so, so popular in Python? Anybody would like to give a little bit touch up on the segment which we are discussing here?
Yeah, sure.
Yes, yes.
So, Pandas is another Python library that is very, I will say, very common. We usually interact with those function that is in the Pandas. So, Pandas is actually
Indeed.
created just to handle the data, just to
Right.
handle the heterogeneous data, especially. NumPy
Perfectly
was
said.
there, but it was very difficult to handle the real world data because real world data is just not in numeric form, or even
Right.
it is in numeric form, it's not like it is in some definite structure. So that's why
Right.
pandas is created over the top of numpy.
Perfectly
So
said,
we
sir.
have,
Very
and
well.
it's rich with the functions. That is the, I will say, the main advantage over the numpy. So many
Right.
functions are there in order to handle the data efficiently.
Right, sir. Perfectly said, sir. Very nicely said. Very nicely elaborated. Especially when it comes to pandas, just like sir gave an overview here. Especially he used the word, if I talk about a familiar word, I hope everyone understands, that is heterogeneity, right? So let me just increase this a bit, maybe. Oh, sorry. Why- Yeah. So I'll use the word. So, uh, first and foremost, just like how Ankit sir has described perfectly, that it was actually, the story goes like this: like we had NumPy very well and good because we were able to manipulate with multi-dimensional arrays because more or less everything which we see around consists of numbers, and the world is completely numeric, but that is true to some extent. But if we talk about, right, real-time objects or real-time data is available in the form of tabular kind of a structure, wherein we mostly describe the things in the terms of, let's say, a row versus a column, right? So most of the real-time data exists in the form of that, right? So uh, the idea was we needed a super refined structure which can interact with the same thing, right? Now there is a bit of a problem with NumPy. Let's understand that. Like we discussed that NumPy is what we discussed about is it is homogeneous, right? So when we talked about NumPy, we said that it accepts data types which are similar to the kind. Like for example, you have started off with an integer, so provide all the integers. So, but in a real-time setup, right, we say that the real world data is not always have to be numeric, right? So there could be categorical columns, there could be X, Y, Z factors which are affecting the stuff. There, obviously, at the end of the day, we use numerics to define some metrics in the context there. But however, if we want to go about talk about categories, it was not so friendly. Like if I say NumPy was not so friendly because it accepted homogeneous data. But on the other hand, what is so similar about pandas and NumPy? We see that both of them, if you see, they look like, what do you say, squares, right? I won't say squares. It could be square or a rectangle, a fully defined shape where you have X number of rows and y number of columns, right? If I talk about, if it is a 2D act, very simply speaking, if I say. So in a way, and we saw that there was one important thing which we saw in our yesterday's class, that it actually looked like a matrix. If I were to draw a matrix in the form of a table, I can very easily draw it because it has exactly the same number of, I mean, if I talk about, I want to know the total number of elements, all I need to do is x multiplied by y, and I get the total number of elements, x, y, z, whatever we talk about, right? So the idea was that what if, because the real-time data which we see across, right, nowadays, if I talk about, I think we have messages across. Perfectly said. Rishikesh sir said it rightly. Yes, awesomely said. Yeah, for data analysis, manipulation, and stuff, right? So now we just we yesterday, as we talked about, right? So x number of rows, y number of columns, and then all you do is multiply them across to get it. But the problem with that is, as we just discussed about, each of them should be of the same. If I talk about the same data type, if I talk about, but however, some in our real world case scenario, that is not it, right? So if I talk about, we might have a name column here, we might have age, we might have, let's say, gender, or maybe height, and we have weight, and so on and so forth, whatever XYZ thing we are talking about, right? And then we have entries, right? So now, if I look if I zoom in, right? So, Ankit sir used the word as heterogeneosity, right? In fact, if I talk about pandas, it is both heterogeneous as well as homogeneous, right? Why? Because if I talk about a column, right, it is homogeneous across the columns. If I talk about, right? However, it is heterogeneous when it comes to the rows, right? If I talk about in the context there, right? So that makes a big difference, because now you are able to introduce variability in the data which you have collected and to analyze it further. But it actually, when we talk about pandas, it gets an edge. Why? Because in the context, they are no longer lists, but they are being stored in the form of numpy arrays at the backend, right? So you're still able to enjoy that super speed functionality with the what do you say, heterogeneous type of data which you have across the rows. I hope that particular fundamentals are clear for all of us, just like how we all know about, right? So just like how it is being described and we have just talked about. So a very powerful data structure for so and so. We have series. A one-dimensional structure is called as a series versus a 2D is a data frame. If I talk about, simplifies data cleaning, transformation, and aggregation. If I talk about, built on top of NumPy, the fundamental need is just like how Sir has also described and many of us talked about, right? It is built on top of NumPy and hence is optimized for performance. Why? Because we have the word numpy here, right? So it handles missing data and so on and so forth. You have different kinds of file formats that can be accessed, right? Not just limited to that. Obviously, now that we are now linked with real-time data, we can do any sort of analysis thanks to working with pandas, if I talk about, right? So obviously, pretty basic stuff. If I talk about, let me just introduce line numbers here. So obviously, we download pandas by using the same thing. Pip install name of the library, that is pandas, and so on and so forth. The current version, if I talk about, I can check the version of pandas by using underscore underscore. So I think more or less everyone understands that this is a property which has been defined. So many of them, if you talk about many of these popular libraries, you can use underscore underscore version to check which version has been installed on the system for, as a matter of fact. So that talks about in the context there. So just like how we have discussed about the concept, obviously the first important thing is which comes up is a series, right? It is basically just like how we have discussed now, a one-dimensional structure or labeled array is basically called as a series, if I talk about, right? Versus a series can be, what do you say? You can create series from different stuff, right? If I talk about a list, dictionary, scalar, or maybe with an index, whatever we talk about, and it has few of the attributes, and most of these attributes are also forwarded to data frames as well. If I talk about, if you want to extract those. So the way we define a series is we just defined up above that import pandas as PD, and then I'm using the class called series. Another thing which we discussed about in my first series of lecture, where we talked about where this series function is actually located, right? I hope everyone recalls that pandas, core, then there is, what do you say, series, and within that, the class called series exists within that, right? So if I talk about, and obviously, I have the data which I'm feeding in the form of this, what you say, list. Uh, or I can talk about in terms of, let's say, I can have my own indices, or if I don't put my indices, it by default initializes it with 0, 1, and 2. If I talk about, let me remove this up for the context here and run it off. Obviously, it talks about, you can see that it shows, it initializes it with 0, 1, and 2 by default. But obviously, I'm trying to access the label B by just like how we know about how we access it in the context there. So that's why I needed. I just kept the indices in the context here. So if I define my indices, you can see A, B, C being printed in the form of indices here. If I talk about. So A is 10, 20, and 30, a very simple, straightforward example. So there's the axis label for B. How do we talk about? That's basically nothing but S dot B. Sorry, S of B if I talk about, or we can also use LOC versus ILOC. We'll talk about it in a jiffy. So, but as of now, you can see ILOC for now, right? So I hope, what's the full form of this? Anybody? What is this?
I think index location.
Yeah, right, sir. Exactly. So index based location accessing. Perfectly said, sir. Exactly. So I is index based location accessing. So in the context that whatever the original index becomes, that is exactly what we are talking about in the context here. So I hope everyone understands. I am putting one here, which technically translates to this is the zeroth position, this becomes the 1st position, and this is the 2nd position. So that's why when we talk about when we try to fetch with 1, right? Access level of B, basically this, right, is exactly the same if I talk about in the context there. So the default indexing, just like how Sir has mentioned in the context there. So index-based location accessing. So very simple and straightforward. If I talk about, I have s dot index to talk about in the context there. I want to fetch all the indices together. I want to just fetch the values. I can do so, right? So you can see s dot d type gives me integer 64 if I talk about in the context there, right? So I hope everyone is clear about the concept there, right? So let's move forward and little bit talk about more in the context there. Hmm. So just like how all of us have mentioned the context there, so let's quickly talk about that. So two-dimensional label data structure is often referred to as a data frame, if I talk about, right? So obviously we can create data frame from any of the sorts there, right? If I talk about, right? So there's a dictionary here. The dictionary contains the key called as name and the value called as Alice, Bob, and Charlie. I think more or less everyone would safely say that the name becomes my header, or I should say column. Then, if I say age becomes my header for the age column, and salary becomes my header for the salary column, and so on and so forth. It creates that ABC or Alice, Bob, Charlie, whatever we call it. Here we have those, right? So it creates so and so forth. I hope. That is perfectly understandable. So we can create our data frame right away with using the what do you say, dictionary data structure as well. So if I talk about, and we have this in the context here, there are a few of the properties which can, let me just introduce these things here so that it's particularly available and easy to interpret the stuff between that. And I run this. So obviously, the very first thing which we have is df.head. I mean, when I talk about head, most of us know about the head property, right? By default, the head takes first five, right? So n equals to by default is five, and that's why it gives us the top five. But in this case, we have just created three. So that means it gives all three of us, I mean, all the three data points to talk about, right? Same way in the context, if I talk about, right, so I have the shape here, right, which defines in the context, like just like how we had numpy ka shape, right? Similarly, we have the data frame shape. So in the context here, the shape of the array, or I should say, the shape of the data frame, right? So I think more or less everyone understands what basically would be a data frame, right? A frame, or basically just like a photo frame, you have frame which contains a photo. Similarly, a frame containing data points in the, what do you say, vertical and the horizontal axis, if I talk about, is basically described to as a data frame, if I talk about. So we have 3 cross 3 in the context of the shape here. There's the df.info, right? Df.info is a very important property which we have because it gives the complete info about the data frame which has been created in the context here, right? So let's quickly look into what df.info contains, right? So first line, df.info contains the first line, which first says, you can see, I hope everyone remembers, right? I told you that the data frame class is located within pandas, core, frame, and data frame. So that is why if I talk about, I told you on that day itself, right? So if I write pandas.core, right, dot frame dot data frame, this also gives me the same thing if I talk about, right? So, but no, nobody likes to write it in a very big format if I talk about. But however, PD, the very short form of which we talk about in the context is data frame. So we directly use pd.data frame in our regular day-to-day activities rather than talking about where is it located. But more or less, as we talked about, right? So we can also use pd.core.frame.dataframe, so on and so forth, to create a data frame as well, right? So same way, if I talk about, I can also create a series. I forgot to talk about that. Maybe I will just take the series here, right? And let me, instead of taking series here, pd dot, the name of the module is core dot, I'll say series is the name of the submodule after that, and there is series. From there, I'm talking about the series class, right? If I talk about in the context, you can see that it says series class, and that is what is happening here. So that's why if I talk about, if I run this, I still be able to look into what is happening at the backend in the context end, right? So more or less, it's particularly understandable, hopefully, by everyone in the context. Just for the reference, if anybody wants it, I will just keep this up. Can check this out, right? We can also write it in the form of I'll probably series, and let me just run it off. So I mean that can also be used for series. So just a quick thought about it, right? Because it is the exact location where these things, I mean, it is actually located, this particular function, or I mean, class, I should say. So this class is located within that. So next, post that, right, we have the shape. We were discussing about df.info, right? So let's see what all things are part of df.info, right? We have class, pandas, core, frame, data frame. So that is what we have, right? So now, if you look into the second line, it says range index 3. That simply means that it has indices. I mean, you can see it shows the word range index, meaning it shows 0 to, if I talk about 3, right? So if I talk about in the context, so that becomes entries become 0 to 2, right? If I talk about in the context, right? So that's what is talking about in the context of the indices, right? Then moving forward, if I talk about, we have the column information, right? So a lot of column information can directly be seen right here. So you can see the name column, which talks about a lot of different details. It says there are three not null values in the name column. So basically, this is also the place where you can identify if there are null or not null values. So if you do df.info for any of the existing stuff, that still brings out on the current stuff as well. And the D type, it says as object, right? You can see the object here if I talk about, right? So, and same way name, and the D type is integer 64. Salary, you can see that int 64, that's the spaces which is being occupied. Then you have the number, counting of the numbers, as in what are the different data types, how many numbers are there. So you can see integer 64, there are two columns which are of that type, and one column which is of type object, right? Then there is a very important stuff which we should technically try to minimize, right? The memory footprint, right? So you can see it shows me memory usage 204 bytes, right? So no doubt about it, there is nothing wrong about it, because in my system, right, if I talk about, right, I have enough memory to hold to, if I go to my task manager, right, I have enough memory to load this stuff up, right? So 8 GB of memory is well good enough. So, I mean, obviously, there will be no big deal if I'm running a 204 bytes stuff. But that is the issue. There's the if I talk about, our idea is to reduce the memory footprint, right? So, and that's what can be done by choosing different kinds of, or changing the data types as well. So we'll look into that in due time. But as of now, you can just keep that in mind, that memory usage should be, we should try to minimize it, because this is a very small data, right? Many times you might have seen that you're loading a very big data set and all of a sudden it says out of memory. I mean, we are like done forward. I mean, done without even moving forward. We are just stuck at that point, right? So we can minimize the memory footprint by understanding what our. So it is very important. The best way to be, I mean, really good in terms of data analysis is to first. I hope everyone, all of us, will agree that the more better we understand about the data at hand, the better we can do the analysis. That makes a big difference, right? So more or less, we have all of this in the context there. Now, after this, you see something called as none here. Can anybody tell me what is this none? Why does it show up? Anyone? Would you like to talk about that? Maybe anyone? Why does it say none? Any ideas? Shouldn't say none. It is getting printed right when we talk about df.info when I'm printing that. So any idea why? Anybody would like to say that? Whatever you feel like, whatever guesses uh, anybody thinks of, anything which comes to mind. Are we all there, by the way? Everyone there?
Yes, yes, yes,
Okay, okay,
Soumya. So
right.
this none is the output of df.info.
It shows me here, right, sir? You can see, let's see. I have this print statement. You see, right, sir? After this, I have put this star mark, right? And before this, I have put a star mark. So you can see that the df.info
Okay,
prior
I
to,
think
yeah.
uh, I like we do not need print statement
Exactly, sir.
in the.
Exactly. Exactly. You got it right. df.info, just like how you mentioned, perfectly said, sir. df.info by itself, in the definition where it is defined, would be having a print statement. I think more or less, just to demonstrate it, what is happening, just like how sir mentioned, I have int, I mean, let's say int 1 equals to 12, and I say print of int 1, I would say like that, I mean, that gives me int 1, right? That is 12. But however, if I use a print statement of the print statement, I think you can understand this is what is exactly happening at the end. So it gives me the type. If I say, I hope everyone understands, this, the type of this is basically nothing but none. I hope everyone understands. But if I say what is the type of this value, which is inside this, that I can say that it is a integer. This is an integer, but I am having a print statement, and I am having a print statement right outside it. Obviously, the print statement itself, when it I hope everyone understands, the print statement is giving us a value which looks like 12, but it is actually not 12 to be specific. Meaning, I can't, the moment I write print, can anybody tell me what will be the output of this? What do you think will be the output of this? Anybody? Oh. I would probably first question would be, I think, int of 1 plus 12. What would be the output of this, what I've written here? What do you think, everyone? Anybody would like to give a idea about, right?
Int one, okay, int one is variable.
Aha, int 1 is a variable called 12, right,
Okay.
sir?
Like if we are using this print int one, that means, oh, okay, int one plus 12. I think this will print 24.
Right, sir. Okay, perfect. And what will be the output for this?
I'm not sure, but print statement is like throwing some string.
Right, sir.
Then it will
Actually,
be like 1212.
It'll be an error, I
no.
guess.
Yeah, exactly, sir.
Error,
I
error
mean,
maybe.
sir, you thought that. I think I understand your logic, which you might have thought. You are thinking that print int one is basically returning maybe a type like string. That's why you said maybe one, two, and then
I thought
depending.
concatenation will happen.
Right, sir. Exactly. But let's see,
Yeah,
just
this
like
will
how we
give
talk.
error, error.
Right, right. So if we say, it says unsupported operand types because the type of this, let's see what I mean by this. So everyone understands this, right? If I say, what do you think will be the output of this? Everyone? If I write,
Integer?
obviously, perfectly said. It says integer, right? Perfect. But what do you think will be the output of this?
Class integer.
This
I
one,
think
sir.
none, na? That's why we are
Yeah.
getting none
Yeah,
type error.
exactly. Exactly. You're right. So the print statements first prints the number 12, then comes out. I'm saying type of this, how, what is this number? Although we are thinking that this number is looking like 12, but obviously it is not an integer. It is none type. Why? Because I have written the print statement. Had there been a return statement, then return returns a value. That is the whole difference between a return versus a print statement. A print statement, whenever we use a print statement, by default, whatever the object may look like, it is never that object. It is always none, if I talk about, right? So because we are using the print statement to talk about. Had there been this, like for example, however, instead of having print, if I said str, what do you think will have been the case here? Anybody? Anybody would like to
Then
try?
this will become string. Obviously,
Perfect. Yeah,
it
exactly.
will
Right.
help
Now
us.
what, yeah, now what do you think?
Then none type.
Yeah, you got it, sir. That's what exactly is happening here. It might look like a string or it might look like an integer, but however, it is not an integer because I'm using exclusive the print statement. Uh, sir, someone has unmuted. Please feel free to ask. Anybody have any questions? Uh, no? Okay. So just like how I think more or less we all understood the concept there. And that is the reason why, since df.info, even if I wrote it without the print statement, this should technically give me the information as well. You can now see that it gives me the context here. So just like how we have described it. So by default, I mean, wherever that info is defined, internally, wherever the info is defined, this actually has a, instead of having a return statement, it has a print statement, which should be printing all of these information out there. So I'm trying to say print and then print of something. So something in those lines. So which is exclusively talking about in the context here that I'm trying to print something which is none type. So that's what we are trying to do here. So more or less, just like how all of us have described, perfectly said, everyone. So that is exactly what is happening now. Next, moving forward, a very important, another big important, what you say, function or I mean a method of a data frame. If I talk about, that's describe, df.describe. Let's look at that quickly. So the df.describe gives us statistical information about the data which we currently are working with, right? So if you look into, right, the age parameter or the, I'm sorry, the age column has so and so parameters if I talk about, right? So by default, it does not include, you can see it has dropped the name column because it is of type, I mean, it is category type. It has taken the numeric form in order to show it up here, right? So more or less, it makes sense to talk about that, right? If I look into the context there. Now, my question, a simple question to everyone, right? So, what are these numbers? What do you think these numbers are? Anybody would like to go ahead and talk about them a little bit? Maybe these numbers which we have here, or these few numbers which we see here, right? Obviously, we know about what's count, what is mean, the standard deviation and stuff, right? And obviously, we also know mean, min and max. Anybody would like to describe these? What are these numbers? Anybody?
They're percentiles, 25 percentile, 50
Exactly.
percentile, 75 percentile.
Exactly, exactly. So you basically, just like how others has mentioned it here, you have a particular data which you are dividing in it into like basically four parts, right? If I talk about here, here, and here, if I talk about, you are basically dividing it into four parts where you have the minimum, you have 25, you have 50, also known as Q1, Q2. You can call this as Q3, 75, and maximum if I talk about in the context there. So that is, so I hope everyone understands that this number, everyone understands the logic that the second number will always be either less than, I mean, greater than or equal to this number. That's what that is one big point which I wanted to raise here, right? So whenever you see this kind of a structure, right, if you talk about, we should understand one thing that the numbers which you see here, they are in the ascending order of the format, if I talk about, right? So that's how we talk about in the context there, right? So okay, can anybody help me with this? Suppose the minimum here you see 70K, right, as a minimum value. Then I say maybe I have what you say 75K as 25 percentile. Again, I have 75K. Can I have something like this? Is this possible? Can anybody tell me? Like in if there is a data like I mean if there is a data of salaries, is this possible? If yes, why? If no, why not? Anybody? Instead of having these values 70, 75, 80, 85, 90, suppose I had some data where I am having this kind of a scenario. Is this possible? What do you think? If yes, why? And if yes, then how? And if no, then why not? Anybody whoever feels like.
I
I
think
mean,
it can. There is no problem in it being the same.
perfect, sir.
It's not like, but it's very rare that in a data set like
Right,
this
sir.
happens.
But how would you interpret it? Brilliantly said, sir. You said that it is possible. Yes, exactly. The one-liner answer would be yes, it is possible. Meaning, what is now? What is the interpretation of this? Well, how we can interpret?
All the all values in that data set will be same.
Okay, nicely
If
said,
all the
sir.
values are same, this might happen. Otherwise, I don't think it will happen usually.
Right, sir. It is actually just like how others as mentioned here, perfectly said. Yes, it is definitely possible. And if you look into it, this is the first quartile or 25 percentile, right? If I say, then this is the 50th percentile. Same way, this is the 75th percentile. When I write like this, can I say that 50% at least, I can say at least 50% of the values are 75K. Can I say that? Meaning, suppose I have 100 data points, okay? I have, what I mean by 100 data points is, I have 100 people's salary here, right? If I talk about in the context, right? So if I look into it, right, I am seeing that if this is the case, suppose the minimum salary out of these 100 people is 70K, and the maximum salary which a person is getting is 90K, right? And in the middle, I have 75K as the three inputs, right? What can you definitely say about this? There are total of, I mean, total data points or total salaries or total people are 100 if I talk about, right? And we have a scenario like this, supposedly. I mean, let's assume as a matter of fact, right? What can be said about this? Maybe. Can I?
One thing is middle value will be 75,000. Second,
Perfect.
50 percentage of the values. 50 percentage of the values will be equal to or less than 75,000.
Yes, perfectly said. I mean, if I talk about, sir, I would say the 50% of the values will be equal to, what do you say? At least 50% of the values. That means the salaries of 50 people in out of this 100 data points can be said to be exactly 70, at least. I'm saying the word at least because I haven't measured what is the 20, I mean 10th percentile, or maybe I haven't measured what is the 90th percentile. So but I know for a fact that if 25% is 75K and 75th percentile is also 75K, that means 75 minus 25, which gives me 50% of the values actually are equal to 75K. That is, as such, how Sir mentioned it. That is exactly what we can talk about in terms of how data is distributed. So, what I mean to say is, numbers speak a lot when we look into. However, the count of the entire thing is very low. If I talk about, we'll look into few more examples below. But I just wanted to give a quick heads up, just like how Adarsh has also mentioned. And I'm very happy that I mean we all like interpret the numbers rather than just what do you see exactly if I talk about in the context there. So you see the 50% of the values could be exact like people are receiving 75K as the salary. I hope it is clear for all the others as well, whatever we have discussed so far. Is it clear for everyone, all of us? Uh,
Yeah, yeah.
Perfectly said, sir.
Yes.
Thank you so much. Perfect. Now let's move forward and look into the context there, right? So we'll look at a little more details and stuff. So now I have my what do you say? I can specifically extract information regarding, let's say, the age or name and the salary. And in order to extract that, it is very important that we use double brackets because I'm trying to retrieve multiple columns. if I retrieve a single column, that's well and good in the context there, right? I can use one of them, right? If I talk about, right? However, if I'm retrieving multiple columns, I should be technically using two brackets, right? I hope that's particularly understandable. However, if I talk about, I think you can all understand that this is also possible. What is the difference between writing a single bracket versus two brackets? Anybody? I can write it this way as well, but anybody would like to elaborate? Maybe I'll just, oh, sorry, that was range. I would say this multiplied by 20. In the meantime, anybody? I have written two brackets. What could be the difference between the two? Both show the same thing, right? Yes, sir.
I'm not very sure, but
Right,
yeah,
sir.
I think it's the if single bracket it returns in the form of series, right? In
Perfect.
DF
Yes,
form.
sir.
DF of age
Awesome.
gives it in the form of this one. The other one, it's double bracket. It's a data frame. It will you have a
Perfectly
data
said.
frame. This
Yes,
one.
sir. Exactly. Exactly. Just like how you said it. If I write, I'm sorry. Let me see the type. We all know the type returns the type of it. You can see it shows class pandas.core.frame.data frame. This is of type data frame, right? However, if I measure this as a single-handed object, you can see it returns a series. Perfectly said, sir. Nicely said. Just like how it talks about in the context there, right? So I can write it in the form of this. Awesome. All right. So I think more or less we understand the concept there, but it is definitely needed that I should be putting two of them, like two brackets here, if I have multiple number of columns, right? And that there is a very simple reason for it. Because I'm fetching multiple columns, it has to be a data frame. A series does not have it in the form of this, right? So if I talk about, right, the moment I try to do this, it shows me up with an error. Let's wait for a, yeah, you can see it shows me a key error showing that it's unable to understand. You can see key errors, it says name and salad, right? So I hope that's particularly clear. So sometimes that's what basically I think everyone would agree that logically that should be the case because I am fetching multiple columns, then I can't imagine. We just said that it should be a series, right? I mean, sorry, it should be a data frame. So that's why we have the same. Let me refresh it. Sometimes this guy it's out of mind. It just gets white. Yeah. So let's move forward here. We were just discussing about that, right? So we have the name and the salary. Where did I go wrong? Let me put this up here. Let's do that. So I think more or less everyone is clear of the concept which we have discussed about here, right? Now, moving forward, we earlier talked about the index-based location accessing versus there is LOC. See, there is nothing wrong in accessing it in this manner, right? But Pandas offers a much more flexible way to, to interpret the data which we have at hand. And that's why we have the LOC, which we can use to locate a particular element or maybe a series or whatever we talk about in the context there, right? So that's what exactly is happening here. I hope everyone understands that df.iloc of 0 returns us the zeroth row. You can see it shows me Alice, 25 and 70,000 as the context there, right? And the second one, if I talk about, you can see also returns me the same thing. Why? Because for a very simple reason, I have the yeah, I forgot to mention one more thing. I generally prefer not to use a print statement to print a data frame because thankfully, what do you say? The data frame, what do you say? Looks really amazing the way it is defined in the form of the data frame class within Python, if I talk about. So it's always good to see it the way it is defined. So it has a nice GUI of its own. So I like this one to more preferably over that. But however, if you have multiple print statement, you can't run it using the variable name. You have to use a print statement. Sadly, in that case, you can just put the data frame and then with the print statement. Now, what I wanted to focus on is you can see the indices are 0, 1, and 2 if I talk about. So that's why even if I use LOC versus ILOC, that's one and the same thing if I talk about, right? Had there been different indices, then in the context there, I could have used that to fetch my details in the concept there, right? So if I say in the I mean definition in the above case, right? So hopefully we can understand the concept there. Post that, just like how we did it in NumPy as well, right? We this the same thing is possible using pandas as well. The conditional based selection, right, or Boolean based, what do you say, indexing to I mean to fetch values which are particularly in that range. So you see df dot I mean df of age, if I talk about greater than 28, if I talk about. And by the way, there is one more thing, one more important stuff which I can talk about. You saw that I can fetch df dot I mean df of age this way. If I want, I can also use df dot age to also fetch the same thing. So both of them work same way. I hope that's particularly clear. I mean, I can either use this or I can use this, right? But obviously for multiple columns, I need to put it in the brackets to look into, right? So I hope everyone understands. If I do this, I hope you can understand that it gives me in the form of a nice, cool looking data frame, the context there, which we have discussed earlier as well. So I hope makes sense to everyone here. Then, as we just discussed about, you have print statement where you are fetching the age greater than 28 and then printing the data frame, right? So in that case, you can see that age 28 is gone. I think Alice was less than that. So you get the context here, right? And you can see I can also use ampersand to fetch using multiple conditions, right? If I talk about in the context there, right? So more or less that makes things amazing to work around with. This is fetching both the same details. I would rather do this maybe so that you have Charlie getting fetched, right? Because Bob has, although he meets this criteria, but he does not meet the criteria for the salary. And that's why this second option becomes nullified here, right? So if I talk about in the context there. So more or less, it's particularly clear for all of us, I think. Now, setting values, if I talk about, right? So I can go to, I can use my LOC to set the values here. You can see the context there, right? I can use 0 of salary. That's exactly what I wanted to talk about because I'm using LOC. That's why I'm saying 0th row and the name of the column is salary. And that's what I'm trying to print it here, right? If I talk about in the context. However, alternatively, just like how you already know, I can also use ILOC, right? ILOC in the context there. So I can say 0, comma, maybe I will say I'll probably say 1 because I want this age to be changed here. And let me just put it as maybe 21 years, right? If I talk about, and let me just do that. You can see that I can use what do you say, ILOC to access the same as well. So hopefully it's particularly understandable by everyone to talk about, right? So more or less, I hope that's particularly clear for all of us here, right? Now, so moving forward, we have how we can handle the missing data in the context of I mean, in the context of our data which we have selected in the data frame, right? So supposedly I have a data frame which is again you can see I have taken a dictionary. The dictionary is containing what do you say? The name of the column is A with the following values. There is a value called none here. I think more or less you can understand that none type is going to fetch the context which we talk about in the context of the data which we have taken in the context here. So you have the none here. There's the none here. If I talk about, let me just also print df2 for reference. Let me do this, a few things more, and so on and so forth, right? So you can see that I have my data frame in the very beginning. That is my second data frame, the df2, which I have. You can see it has none there in place, right? So obviously, there's the first function which we talk about is null, which is checking whether if it is null, and that's based on, obviously, I'm asking the question, is the data null or is the data none, right? So obviously we can expect the answer in the form of a true or a false statement. So you can see these two return false versus the third one return true. So that's if I want to do the opposite, you have not null. Obviously, it's just the transpose of it, and so on and so forth. The info, if you talk about in the context, right? So you can see that there are three indices, but the not null count shows me two here. So I think more or less we can also get the idea about how many values are missing in the context there, right? So more or less, this is what I wanted to discuss about. You have the memory footprint here, and obviously, as we discussed about, no need for the print statement. I think we understand the context here, right? So to drop off that none. And post that, to talk about, I hope we understand the context here, right? The drop NA functionality, if I talk about, right, which helps us to drop the particular values based on the context there. You can see those two are removed from consideration, right? And the first row is taken in the concept there, right? If I talk about, you can see the context there, right? So I can also provide the access equal to 1. I think more or less, anybody can anybody tell me why does it return this empty stuff? Anyone? Why do you think it returns empty? Let me put df2 for reference here. Why does this return empty data frame? Anybody? Okay. Anyone?
Because I guess there is no null value, right? So that's why we are getting.
Actually, sir, if you see, when I say by default, it was, let me show you. When I say drop NA, it is by default with access equal to 0. That means, let me run this again. If you look into access equal to 0 simply means, just like how we have discussed, row access, right? So if I say in the row access, there is a none here, there is a none here, and that's why that entire thing, this is removed versus also this is also removed, right? So the only one which is remaining is this guy here, right? So that is why for access equal to 0, you have this particular value, right? However, if I talk about access equal to 1, which is now becomes the column access, right? You have two of them, right? If I talk about in the context there, right? Now, in each of the columns, you have none values, right? If I talk about, right? And when I'm trying to drop the NA values there, if you talk about, right, it drops both the columns. And that is why, because both of them are containing none values, right? If I talk about, and that is why it gets dropped off from consideration. And that's why at the end, you have an empty data frame to talk about. Is it understandable, all of us? So axis 1 is the columnar axis versus perfect set. Axis 0 is the row axis to talk about. So I hope that's particularly understandable. More things that will be particularly clear, but obviously dropping is the last thing which we should do. Initially, the idea is to fill the missing value. That's the whole point, right? So you don't want to lose a lot of data. That's the whole point, right? The last resort which we should shift towards is to drop it off. But if it is possible to impute the data or replace the data with something else, then always choose that path, right? That's the first thing which we should do. Because anyways, we know that there's scarcity of data if it is very old data. So the more the data which we retain, the better we do in the form of understanding the concepts there. or maybe finding more patterns, right? So here, if I talk about, right, the method which we use, right, for what do you say, filling the missing values is the fill NA, right? I want to fill the first one being fill NA 0. That particularly, I hope everyone can understand by the word itself. I'm trying to fill the value as 0 in the place of nan values, right? And hopefully we can understand that it is going to give me zeros in place of the nan values. That helps me sort out the nan values in the context there. I hope that is particularly understandable, right? Now, again, there are a few parameters which I can consider within the fill in NA, like number one, as what do you say if I talk about the method, right? So under the method, I have one called as ffill, or otherwise very popularly known as forward filling, right? So in the case of the forward filling, what happens in forward filling? Anybody would like me to elaborate a little bit? What does happen in forward filling? Anybody would like to talk about?
The next value of the empty value will consider that.
Perfect, sir. Meaning you basically, what do you say, take the first, I mean, previous value. So suppose I have something like, just like how sir has mentioned, let's say I have 20, I have 19, maybe let's say I have 22, maybe there is nothing here, there is nothing here. In that case, let's say 19, again, maybe nothing, maybe 18 here. In that case, you have what forward filling does. It goes from top to down, right, and fills the next cell with the previous value. So 22 gets filled with, what do you say, this nan value, which was earlier nan, gets filled with number 22. Same way, now that it has been filled, the same 22 goes into the next cell, right? So if I talk about, then you go next, there is already a value, no need to replace it. Then it moves towards the next. There is 19 here, so 19 gets filled here. So I think more or less, this is one of the methods by which we also do. So this is, since we are moving in the forward, we call this downward direction as a forward direction, basically, if I talk about, right? So from top to bottom, or maybe if I, maybe if this was an array, right? You take a transpose of it, it becomes like this, right? In that way, you can understand a forward fill, right? So it will be like 20, 19, 22, and 22, 22, and so on and so forth, right? So that will be the forward direction. So that's what you're talking about, right? So you fill in the forward direction, one after the other. The values which are not filled, they get filled up based on the values in the previous set. All good, everyone, right? So that is the idea of forward filling, right? So same way you have the reverse idea as well, where you talk about backward filling in the context, wherein this value becomes this. So in the case of backward filling, this becomes 18, right? I hope everyone understands. Then again, this is 19. So 19 gets filled here. I hope everyone understands. Then 19 gets filled here again because this was a blank. Then move forward. There are already numbers here. I hope everyone understands this. Is it clear for everyone? Yes or no? All of us understood the concept there?
Yes.
Perfect. Perfect. Thanks. All right. So that is the idea of forward filling versus backward filling, right? But in the case of the B, right, you can see there's a small twist here, right? And an interesting twist here. The column B has the first value as nan, right? So if I use forward filling, then I mean it is already nan, so there is nothing on top of it. And that is why if you look into, can you see this? It shows me nan on top here. But for the case of column A, you can see 1, then 2, then obviously because of forward filling, the second column, I'm sorry, the second row gets filled with the number 2. And that is what you can see here as well, right? Number 2 gets filled in the value there, value placed there. But there is nothing here because I've used the method as forward fill. I think you can understand B fill, if I talk about, right, in the context here, you can see the opposite happens, right? Here you have nan, right? Because the lower one was nan, right? And 2 gets filled here. Is it Clear for all of us? Did we all understand the concept there? Is it understandable? All of us? Easy to interpret, right? Especially methods like bfill and ffill. All good, everyone, right? So, if I move forward, right, if I talk about, right, you have the of 2, right, of column A, if I talk about, I'm trying to fill the NA value with, this is much more logically suitable because, I mean, it depends on the data which you have, right? Whether you should employ methods like bfill or ffill, depends on the data. But many a times, right, if what do you say? If the data is can anybody tell me? Yeah, I have a very interesting question for everyone, right? Can anybody tell me, right? I can also, what do you say? Fill it, let's say I'm talking about column A right here in this context, right? And I'm trying to fill it with the mean, right? In this context here, right? So when can I use a mean versus when can I use median? Can anybody tell me? What what do you think? Anybody would like to talk about that? When can we use mean versus when can we use median to substitute the stuff? Anybody?
So based on outliers, data.
Perfect,
Median
sir.
is
And
common outliers.
right, perfect. So if there are outliers, then what would you choose, sir? You'd choose which one?
We'll be using median.
Median. Perfectly said, right, sir. Exactly. So I hope everyone, all of us agree with that. All of the others, right? Do we all understand the context here, which we are discussing? Why should we use median? Because median is not prone to outliers. How? Because in a way you are ascending, making it ascending or descending order, and you're taking the middlemost two elements. If every value is an outlier, then there is no outlier to talk about, right? So it is true that an outlier can. By the way, my one more question to everyone is, can an outlier exist in the middle of the data series after what you say, doing ascending or descending order? Did we all follow up the question? Can an outlier value exist in the middle of the series after doing ascending or descending order?
No.
No. Perfectly said.
Usually these are
Yeah.
high change, so I will say not possible. But yeah, sometimes like for the complex real-time data, it may possible.
Mhm. So, sir, like for example, which scenario? Can you give an
Yeah, yeah.
example? Yeah.
For example,
Mhm.
if a time, like for example, a time series is there, and we are
Right.
having a long time series, and for
Right, sir.
example, there are a sudden regime change also in the series. So I will share one graph now
Awesome,
in the
sir.
chat.
That would
Mhm.
perfect, sir.
So
Perfect. So
usually,
you
if outliers is there, these are high change points. So maybe it like if it is in ascending descending order, it will go
right,
maybe in
sir.
the right or maybe in the left. Usually.
Maybe in the left. Yeah, exactly. It generally goes either towards the two extremes, right? Unless and until we are locally focusing on something which may wind up giving
Yeah,
us
exactly. You got the
something.
point. Means,
Right,
if series is long, then we also need to focus. We need to divide the series into windows, and then we have to
right.
focus locally whether the high change point is actually an outlier, or this is the part of
Or
change in the environment, or
in the entire
change in
environment.
that domain. Yes.
Perfectly said, sir. Perfectly said. Nicely said, sir. Yes, definitely. Whether depending just like how the context, as the context windows changes, you tend to change the stuff if I talk about. Thank you so much, sir. So, but more or less in a general case scenario, if you take the entire set of data points, you usually have these outliers in either of the extreme pointers, either towards the lower side or the higher side. And that's why median is much more suitable, just like Adarsh and Ankit sir has mentioned here. I hope everyone is clear on the concept there. Perfectly said. Now, okay, so now that we have this stuff here, you can see that I'm trying to fill the NA values by, I took the DF2 of A. The column A contains the number 1, 2. And if I talk about the NaN value, if I talk about in the context there, right? So you can see that I'm taking the mean of this same, right? I've taken 1 plus 2 divided by 2 in the context, and we wind up getting the number as 1.5, which gets filled in the context, in the context which we are describing there, right? So I think more or less you can understand that this helps things to be much more generalized towards the data rather than talking about methods like bfill versus ffill. For a very small generic data, you can definitely use this in the perspective there. Very generic data if I talk about, but however, for specialized cases, it's always better to use some kind of a statistical measure to measure the particular stuff at hand. So just like how we have described here. Now, let me move forward, and I think you can see these future warnings coming up. Maybe in the next versions, we might not have this method. We might have a new way of looking. You can see use object.ffill. You can use directly this as well. You can see that it shows me in the context there. So df.ffill, I can probably talk about and do the forward filling, but maybe it will be deprecated in the future. So these small red boxes are gem to talk about when it comes to understanding how the how Python may or may not remove certain features in forthcoming updates, right? So more or less, just like how we have discussed here, right? That's the overall crux behind talking about it, right? And yeah, so there's the next set of stuff. If I talk about, by the way, let's see our DF here. I think I think this was DF2. Yeah, you saw I did that, those entire changes here, right? But you see that the changes are not permanent. You can't see those permanent changes, right? And for that stuff, right, more or less, we have many times what we talk about in the context there, there is a parameter called in place, which is by default set as false, right? Which can be set to true, right? In place equals true. I think more or less everyone understands the concept here. What this in place does is replaces the current value with the uh, replaces the current data frame with the updated values in the context there. So that will be a permanent change, right? So you can see that I have df2 dot, a, and I'm using the fill na method. I should be careful. I can also use in place equals to true, because the parameter, it is by default set as false, meaning it is not going to replace the values, but I want this change to be permanent. I want this change to be permanent, right? But it was not permanent when I saw this, right? I hope everyone understands. That's why I'm using in place equals to true. And there are a few more warnings, nothing to worry about those warnings. Let's move forward and check it out. You can see that now the complete data frame is particularly, what do you say, filled up with the current set of values in the context there. So the in place is a parameter which you will find more or less in many of the methods of data frame. I hope everyone understands the concept there. So guys, I think it is 3:19. I took 5 more minutes. I'll probably will take a quick 15 minutes break, and we will return post that. All good, everyone? Is that okay for everyone? I think more or less everyone is out of break, already on break.
Good.
Yeah, cool, sir. Thank you. Let's have a quick break. everyone. Mm, Am I audible to all of us here? Are we all there?
Yes, yes.
Okay, perfect. Thank you so much, sir. All right, so welcome back after the brief break. So, is let's start off with a little more interesting stuff here, which will talk about in the context now. So obviously, pretty straightforward. If I talk about there's the rename feature, or if I talk about the rename functionality, which can help us to rename the columns. It can also this is also capable to capable enough to rename even the indices as well. So we can do both of them. If I talk about, you saw earlier, the name of the column was this. As I said, rather than talking about having print statements, it's better to use the DF to see a nice, cool aesthetic of the data frame. If I talk about, you can see employee name in the context, and I have used in place equal to true. So that means it is permanent change. So I think that's already visible here. So DF has the permanent change here. Now, there's the next thing which I wanted to talk about a little bit in terms of the what do you say data types, which are basically which we are using here, right? So let me just do this. I hope everyone understands. Guys, you saw that we have used like if you talk about the DF, right? We have the employee name, age, salary, and bonus, right? So earlier I had gone to we have seen df.info, right, where I told you that it is important how we manage our memory, right? So currently, if you look into the current memory being used is 228 bytes, right? For running, for these columns which are getting, which we are, which are there for this particular data, right? So you see it is 228, right? So suppose it was a very big data, right? So what we do is basically, right, I can use the as type as type method to change my data type, right? And we know, like as I said, that it is very important. Let me put this into perspective so that everyone can get a better idea here. First and foremost, I would say that float data type is, I won't, obviously, I told you, right? If we want to be really proficient with data analysis, it's always good to study the columns which we have. So here we have the column called age, right? And we know that a person's age, max a person's age he can live up till maybe 100 years or 120 years or maybe something unless and until he is from Japan or something where the survival. I mean, if I say the bar set is like let's say 120 or 130, right? So the idea here is to say that you can see that it shows here int 64, right? It shows us here as int 64, which contains a lot of what do you say data into it, right? So if I talk about integer 64, that is can anybody tell me what is the range of this? Would anybody like to tell me what is the range of this uh, stuff? I mean, when I write int 64, can anybody tell me what is that actually? How, what are the numbers it can accept? Anybody?
I think 2 to the power 64.
Exactly, sir. See, sir, rightly said, very close, right? So when I say int 64, integer 64, basically, when I say integer, right? So an integer can be negative, zero, or positive as well, right? So that is why when I talk about integer, right? So since it is int 64, the first bit is being reserved for sign, okay? And except for that, there will be 63 places. So I would say, I mean, if I talk about 2 to the power of 63, negative 2 to the power of 63, 2, it will be positive 2 to the power of 63. Is it understandable by everyone? Raja sir, I think that there was a little bit of a, I mean, that's only one thing which I wanted to add up here, sir. So, as said
Yes.
by you, sir. Perfectly said, sir. So that is the integer because I'm using int 64. That is 64 bits if I talk about, and I think everyone agrees that this guy is a very big number, right? And since I am keeping the first bit as a signed bit, right? If I talk about, right? Meaning the first bit, there are 64 places. If I talk about, the first bit is being reserved for signed, right? And the rest of the bits are for storing the numbers, right? So the rest of it, right, if I talk about I mean, it is 2 to the power of 63, in fact, minus 2 to the power of 63, 2 positive 2, because I think everyone understands and safely everyone will agree with me that when I say minus 2 to the power of 63 to 2 to the power of 63, this is nothing but actually 2 times that of 2 to the power of 63, if I talk about. Everyone agrees with this, whatever I've written? Anyone confused with this? Please let me know. Is it clear for everyone? Can I say that minus 2 to the power of 63 to 2 to the power of 63 is basically 2 multiplied by 2 to the power of 63? Is everyone clear about it, right? If not, please let me know. I'll just elaborate a little bit more on that. But however, I think more or less it makes sense because this is nothing but negative 2 to the power of 63, 2, 0, one batch, and maybe 1 to 2 to the power of 63 is the second batch. So this is 2 times that of this, if I can talk about, right? So that is why the total number of numbers will be in the context. So anyways, the total numbers are, if I talk about 2 to the power of 64, if in the context to describe to, right? So that's why I have mainly. So I think now my major question is that 2 to the power of 64 or 63, let's say I'm saying 63 or 64, whatever, this guy is a very, 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 very big number, right? I think everyone would agree with that, right? It's a very big number, 2 to the power. That, I mean, even the total number of atoms in the entire universe do not sum up to that number. So it's a very big number, right? So I hope everyone agrees with me on this context, right? So practically having integer 64 being defined for age is, I mean, it's like wasting a lot of spaces for doing some more useful tasks. Do we all agree with that? Are we all understanding the concept here, which I have talked about? Everyone, all of us? Yes, no, maybe? Did we all
Yes,
follow
Soumya.
up? Perfect, sir. Thank you so much. Awesome, sir. So since it is 2 to the power of 63, a very big number, I mean, if I talk about in the context there, right? So obviously, I'm not sure whether I'll be able to do that here. So 63 you can see that's a very big number, right? So 2 to the power of 63 is practically virtually a very big number, right? Generally, we don't use that in the context to talk about in the I mean, this is this big of a number. I hope everyone understands. For the case of age, is not needed, at least not for the case of age. I hope everyone agrees, right? Unless and until we are doing something like encryption, where we may need, I mean, this is not even, no one takes this small of a number. They talk about 2 to the power, I mean, 256 bit encryption is 2 to the power of 256. So that's a very big number again, right? So if I talk about, and you take a prime number so that no one can break that encryption, and that's how you make the system secured, right? If I talk about in a very simple general sense, right? So the idea here is I want to reduce the memory footprint for first, let me say my age column does not need integer 64. Instead, I would say that maybe, and by the way, yeah, there is one more thing which I wanted to discuss about, right? So there is one called as int 64, The other one called as UINT64. Can anybody tell me what is UINT64 if I say? What would this be?
Unsigned.
Perfectly said, sir. Exactly. U stands for, just like sir said, unsigned integer. So since it is unsigned, meaning there is no sign, everything is a positive value. So meaning you're not wasting any space anywhere for storing sign, right? That's why you use the word unsigned, right? So if I talk about, so 0, 2, that's why this becomes 2 to the power. Total number of numbers available would be 2 to the power of 64 because you start from 0, there are no negative numbers getting included, and that's the whole point, right? So I hope that's understandable. So can anybody tell me if I were to choose the kind of data type for the age column, should I choose int or should I choose uint? For the age
I think
column,
unsigned.
perfectly said, sir. A person cannot have a negative, I mean, age, right? A person cannot, I cannot say that others is, or maybe Saumya is minus 30 years old, right? If I talk about, right? Or negative 30 years old, right? Or maybe negative 28 years old, right? If I talk about in the context, right? So that's the whole point, right? That's a funny aspect, right? So in that case, if I talk about, right, the age factor becomes like having integer defined would, I mean, sorry, having uint defined would be a better choice than compared to a what do you say, integer. Oh, perfect. Sir has written that very big number. Awesome, sir. So thanks so much, sir. I mean, you can see, right? 18 followed by 3 to the power of 1, 2, 3, 4, 5, 6. So
Is 2 to the power
18 digits.
64.
Yeah, right. Perfectly said, sir. Awesomely done. Nice. So that's a very big number, right? So, and virtually speaking, n- can a person have that big of a salary? I don't think unless and until we are talking about top 0.0001%. And I mean, this is even not virtually possible. No one, not a single person can have that much amount of wealth. So I think having integer 64 again for salary becomes meaningless. Don't we all agree with that? Everyone would agree with me on this aspect. What do you say? Is it what do others feel? Is I mean, it is overrated, right? I think you can understand. But because how the data frame is defined, it by default takes integer 64. So our idea should be minimize the memory footprint, right? We should not give much more pressure because nowadays, no one talks about space complexity because uh, I mean, there are devices which are having, let's say, 64 GB of RAM. No one is worried about it. People are worried about time complexity. But still, in the context, if it is a very huge data, like you are training an LLM, you would definitely like to, what do you say, have little, I mean, little less floating point precision. We use that as a notion to discuss about how you can reduce the memory footprint so that you do not run out of memory. Is it clear for everyone? Are we all on the same page? Yes or no? Uh, all of us? Perfect, perfect. Thanks so much, Ankit sir. So I think more or less we all agree to this point that I mean, having it's overkill, right? Having integer 64 for age column is like overkill. No one wants 2 to the power of 64 bits to store age. Similarly, for having salary, again, no one would like to have that. Same way for bonus, maybe, if I talk about, right? So in the context here, I'll just quickly talk about that, right? If in the context here. So in that case, see, currently you can see the memory usage is 228.0 bytes if you look into it, right? Now let me, that is the reason why you might have seen NumPy has, what do you say, sub data types, right? That is the sole reason why NumPy has sub data types to work around with, right? So if I talk about in the context here, right? So now if you look into, right, so I'm importing NumPy let's see what we can do here. So I have the age column. Currently, the age column is containing integer 64 bits, which is an overkill. I don't want to use this much amount of memory as well, right? So for reference, let me keep this as a reference. Let's see, do we change anything? I will keep it as a reference. So um, current, what do you say? Current DF using memory so and so, right? If I talk about, let me reduce it a little bit further, the size. Huh. So I'm just keeping it for reference, right? Now I'm changing the as type. I'm using as type. Let me use a numpy. What do you say? Um, what do you say? I'm reducing it a bit. So you see that we had used numpy, 64-bit, right? I'm going to reduce it a little bit, right? If I talk about, let's say, to 16, right? Obviously, 16 is also a big number considering the age factor which we are talking about, right? But if you look into, right, so in the context here, right, np dot context here, right, you can see df.d types. It shows me that age. You can see that the memory footprint has been reduced a bit, right? You can see that it has become integer 16. Now, let's see the difference, right? Let me import this again. Let me run this again. You can see now. Can you see this? The memory usage from the earlier 228 has been reduced to 210 bytes. You have reduced the memory footprint, right? So if I talk about, let me put this into perspective. I will, yeah. So maybe age with age column, column with np dot int 60. I'm using that, right? But still, I hope we all agree that 2 to the power of 16 is also a very big number, right? I would rather maybe, let's say I switch to uint, right? You can see I'm giving unsigned integer here, right? And if in the context or in perspective, if I run it, you see that both of them have the same kind of memory usage, be it integer 16 or uint, because the total number of spaces occupied by int 16 and u int 16 is the same, right? It's just that one is allowing negative numbers also, the other one is allowing only positive from 0 to the next, right? Am I making sense to everyone here? Is it clear to all of us? Yeah? Anyone feels a little bit exaggerated or something? Is
Actually,
it
Saumya,
understandable?
a little bit add up on this.
Right, sir. Yes, sir.
Uh,
Please,
my point of
please
view,
follow.
actually, in case of like integer, actually the whatever we
Mhm.
are taking, like for example, if you are taking 16, okay,
Mhm.
positive side that which will be taken as a 2 to the power 8, and a negative
Right,
side
sir.
also it is taken as a 2 to the power 8. This
Right, sir.
half of the number, okay, and the
Okay.
negative side, the one bit is considered for the sign bit. My point of view,
Uh,
because
okay,
y
sir.
means actually, if you are talking about integer, it has to be occupy more memory as you elaborated. Like negative side also, like 2 to the power minus something, minus 64 something,
Right,
and
sir.
the positive side
Right,
also,
sir.
if you are taking 2 to the power minus sorry, plus 64. So the both the
Uh,
side actually it is occupying the whatever the like the power, the value which is coming.
right, sir.
Okay,
Yeah,
I think
exactly.
my point of view,
Yeah.
it is like split, like half of the number that is
Half
called,
of
like if you are talking about 64, then 2 to the power 32 in positive side, 2 to the power 32 in minus side. My point of view, if
okay.
I'm not wrong.
Uh, sir, there is a little bit of a twist here. Let me elaborate, sir. Nice point raised, sir, here, right? I would like to elaborate a little bit now that we are discussing this, right? So
Yeah.
awesomely said, but I'll just add up here. Let's not go to big one. Let's say maybe, sir, I think I will reduce it. Let's say 2 to the power of 8. Let's go to 2 to the power of 8. It will be easy to interpret. So, sir, as per your point of view, you are saying 2 to the power of minus 4 on the left and 2 to the power of 4 to the right. That's what you're saying, right, sir?
Yes.
If it is 2 to the power of 8, if you are talking about 2 to the power of 8,
No, no.
then
My
towards the
point
left.
is that actually 2 to the power of 8 is equal to like 256 will come. Okay,
Correct, sir.
256.
Correct,
Then we
sir.
are putting 256 divided by like 2. Something
Right,
like
sir.
127.
128.
Uh,
Yes, sir. Yes, sir.
that
Huh?
like that will come.
Yeah. Yeah,
127 something
exactly.
will come.
Exactly. Exactly.
Yeah,
Exactly, sir. You're right. Sir,
yeah. That
that is
is
the
what
thing.
like one side and like negative side and positive
Ha,
side.
ha, ha. So actually, it is not 4. It should be technically, it should be not 4. It should be 2 to the power of 7 on the negative side and 2 to the power of 7 on the positive side. This side 2 to the power of 7. Why? Because 2 to the power of 7 is 128. Roughly, I'm just giving an example here. I mean, 2 to the power
Addition,
of 7
addition.
if I talk. Yeah. Sorry, sir.
Due to addition, we are adding
Yeah,
these two numbers.
exactly.
That's why.
Exactly. Exactly, sir. Exactly. We are
Ah,
adding 2 to the power of, yeah. So that
128.
is why, sir, yeah, that is why, based on that logic, I said 2 to the power of 63, 64 should have 2 to the power of 63 on the left and 2 to the power of 64 on 63 on the right. And that is why, because, sir, if I add this, technically it is nothing but 2 into 2 to the power of 63, which is nothing but 2 to the power of 1 into 2 to the power of 63. This becomes 2 to the power of 1 plus 63. That is why it is 2 to the power of 64. That's the kind of calculation which we are talking about. So same way, sir, in
Yeah,
this case, also the
this is what
small.
I also
Perfect,
explained.
perfect, sir.
Yeah.
Yeah, exactly, exactly, sir. Perfectly said. Exactly. My question to everyone here, perfectly said by Raza sir here. I just want to ask one more thing. Should it be this or should it be this? Can anybody tell me that? This or this? Which one
It
is
should be
correct?
second one. Minus 2 to
Yeah,
power 7.
perfect. Perfect. Exactly, sir. Why? Because when I write 2 to the power of minus 7, this is nothing but 1 by 2 to the power of 7, which becomes a fraction, basically, right, sir? So it is like 1 by 128, which is a decimal point number, 0 point something, whatever, x, y, z. So this is never 2 to the power of minus 7. It is minus 2 to the power of 7, which we talk about. So from the negative side to the positive side, just like how sir has every one of us have elaborated. Now, I think, so tell me, now that we all have seen the logic behind here, right? So, which data type do all of us think would be suitable for age? Which kind of data type should be suitable for age? What kind of data type should I choose
It
here?
should be, I guess,
Anybody?
unsigned, right? That you have mentioned here.
Perfect. Awesome. Awesome, sir. Awesome. Unsigned. And which one would you like to choose? There is int 64, int 32, int 16, int 8. Which one would you like to choose?
For the better memory
In-
management, I guess int 8 would be better. But of
Perfect.
course,
Yes.
like it would
Ah,
store less number.
right, sir.
So there's no need, I guess, right? Large numbers for
So,
each.
sir,
Yeah.
yeah, exactly. Exactly. There is no person unless and until you are a Baba or something, sir. You can live for 10,000 years. They are exception.
There's my
So, no.
there's my
Yeah.
grandmother's mother is surviving. She is of
Okay, sir.
120 age.
Wow, sir. That's awesome.
Yeah.
That's
So
awesome, sir.
in that
That's
case,
that's
maybe we
awesome.
can get confused.
Yeah, but they again, sir, don't you think that is like an outlier in the case of the ages also, right? If you talk about, generally people won't be, but very nice. Sir. It's really good to have that. So as sir said, 120 years. That's awesome. I mean, yeah, sir. Some of
even
us
though
have
We can
seen
Yeah.
that.
consider
Soumya,
for the
even if
age
it is like
128
Yes, sir.
3-digit number, okay,
Right,
3-digit
sir.
number, it
Right.
goes
or
up to triple
64.
nine.
For the
Triple
Okay,
employee
nine.
64.
Exactly, sir. Exactly.
Uh,
Sir.
for the age, we can consider 128.
Exactly. So, I mean, realistically speaking, an age can be of UINT8 maximum, or I can even, I would rather choose UINT8 rather than talking about INT8 because INT8, everyone agrees, right? It will also consider my negative sign. So, it will be from minus 127 all the way to 128, I believe, if I talk about, right? So, if this is integer 8, does any person have negative age? I believe not, right? No one has negative ages. We don't talk about the age quantity in a negative form, right? That is why I would rather stick to the other one, which is like uint8 rather than talking about int. Do we all agree with this? I think. And uint8 will also give us 256 spaces, right? So it is, I mean, in the rare case scenario, even if it is babas and stuff, they can also be accommodated within the age of 256, I believe. I mean, under the case, under the hood, I'm just talking about in a very general case scenario. Everyone agrees with this, right?
Yes,
Yeah,
yes.
sir. Perfect, sir. Perfect, perfect.
No,
So,
little bit confusion,
right.
Saumya,
Yeah,
actually.
yes, sir. Yes, sir. Please. Please.
Even for example, if your age is going max by 3 digit, so it can
Right.
reach up to 999, right?
Sir, but it will never reach to that. Why? Because if I use uint8, because the maximum three-digit
No, no.
number it can
My
be is
question is
256,
that
right?
my question
Ha,
is
sir.
I'm just talking about the figure of the age. Okay.
Right, sir.
Even if
If
you
it
are
is three-digit,
considering if it is 2 digit, maximum 99. Okay. If
right,
it
sir.
is we are
Mhm.
considering 3 digit, then at max it is 999.
999. Perfectly said, sir.
Yeah,
Yes.
okay. But
Hmm.
my point of view, actually, it is
Hmm.
consuming only 3 digit to represent the age, which is required only
Ah,
3 digit. Okay.
yes,
Each
sir.
digit
Yeah, right.
consider of 4 byte.
Four
Okay.
byte.
Two
Exactly, sir.
digit
Exactly.
consist of
Mhm.
like yeah 8 bit. 8 bit consider of 1 byte.
Yeah, correct.
That
Exactly,
means
sir. Perfectly said.
that means we can
Meaning,
represent within the 4 bit itself. Okay. For example, if you
yes.
are mentioning this one, I think my point of view, which will consume 1.5 byte, even not 2 byte,
Okay. So yeah, I mean, yeah, yeah,
to
exactly.
represent the
Huh.
age.
To represent. Yeah, right, sir. If I say exactly, sir, because if I say 8 bits, that is equal to 1 byte, right? One, two, three, four, five,
Yeah,
six, seven,
yeah.
and eight. Yeah, yeah.
1 byte
One
means
byte.
we can represent 2 digit.
Yeah, exactly, exactly, sir. Right. 8 bits,
Hmm.
right? Right, exactly. So if I talk about that is nothing but 2 to the power of 8 in a very big sense. If I talk about, right, sir. So that's the biggest possible outcome which we can have,
That's
right,
what
sir?
actually
Yeah.
my point of
A
view. There is
single
no
byte.
need of going like 16, 64 or 32,
Ha,
64 also.
that is
8 is more than
that's correct.
sufficient represent the
8
age.
is perfect. Exactly, sir. That is why we don't need to even go to 16. That's exactly what I was trying to make the things understand here. Perfectly said, sir. That's exactly. So we don't need this thing. I can still reduce it to u integer 8. I believe just like how Raja sir said, and I think more or less everyone of us will agree to that. And now let's see. If I do that, let me change this guy here from u integer 16 to u int 8. Let's do that. Now you can see the age limit has been changed to u integer 8. And let me run the df.info again. You can see that the memory footprint is again reduced. Now it is 207 bytes. So you are even using less to talk about. You are able to achieve more, but using less resources to talk about. Perfectly said. We had a nice, healthy discussion around all of this. I'm very happy to see the responses here. Just like, yeah, Rishikesh sir has also mentioned and many of us have already talked about, right? Perfectly said. I hope everyone agrees to that, right? So awesome, awesome, nice, as discussed about, right? So same way, I think everyone agrees to this that there is no need to go to integer 64 for salary stuff, right? Which can be probably, I think, I would say 2 to the power of 32. Again, it is a very big number if I talk about, right, in the context. So, uh, million, billion. Oh, people don't have salaries in 4 billion. So I mean, I think you can accommodate that, right? I believe
I
that's the
think
whole point. So if it is, yeah, sir.
Sundar
Fine.
Pichai's salary can be this, right?
Yeah, yeah,
So we can
exactly, sir. I
consider.
wanted to Yeah, sir. But yeah, exactly, sir. We'll probably say the highest salary for maybe Sundar Pichai or
But
maybe Elon
uh,
Musk. Yeah, he's
yeah, yeah.
extracting a lot, it seems. I
Currently,
mean,
I guess
sir,
it's got
there,
updated to
yeah, sir.
September, I
There was
guess.
a yeah, exactly. Sir, but somewhere I think 4 to 5 months ago, I saw this newspaper article which said that the highest paid guy is currently as a CEO is I think Elon Musk, and he's extracting 4 times, or I think yeah, 4 to 5 times more than that of the the second highest person. So there's a very big, huge margin to his salary. It seems Tesla is
Yeah, yeah,
offering him that much. So
yeah.
yeah,
The first two differences are very high actually.
yeah, exactly. Sir. The first person who is earning the highest salary versus the second one. So I mean that's a fun
So that's
note
a
to
outlier,
all.
right? Basically.
Yeah, exactly, sir. You are right about it. Again, it's we don't generally consider that big of a salary. Generally, people you don't find that as a normal salaried person unless you. I mean, Tesla has everything to do with that guy.
Yeah,
So I mean, what to
that
say?
can be
Yeah,
outlier, I guess.
yeah, exactly, sir. Exactly. So that's the whole point. So just like how we all have had a healthy discussion here, so I think more or less everyone agrees that the salary, I would rather say, I would maybe I'll where is it? Yeah. Sometimes it acts weird. So salary, I would rather stick my salary to np dot uint 32 unless and until I mean it will even accommodate his salary as well. So I think if I go down here, now you can see the salary has been also reduced to U integer 32, and you can see the memory footprint. It is way reduced. So initially we started from 228. We have reduced it to a very, I mean, to a large extent. To if I talk about same way, I think everyone agrees that a salary can, I mean, the bonus cannot be greater than the salary. So I think it would be safe to put the bonus way more lesser than that of the salary, or maybe equivalent to it. Because, dude, have we seen any scenario where a person's salary is 100 rupees and he gets a bonus of 100 rupees? That never happens, right? Under very strict circumstances, unless he has, what do you say? Does that happen, sir,
Like
often?
I think if you are comparing with monthly salary, then that can be the like that
Case,
can be
maybe, sir.
somewhere like we can get a bonus of 2 to 3 months like that equivalent.
But yeah, but sir, suppose our salary is, let's say, 5 lakhs, then you can't get a
Mhm.
bonus of 5 lakhs, right, sir? I mean, it can be a fraction of it, like 20,000, 30,000, or maybe a lakh of bonus, but not exactly 5 lakhs because his salary
But I
is
have
capped
heard
at
in
5
some
lakhs.
company like 35 LPI is there. So
Oh, okay.
5 lakhs should be kind of a bonus, and 2 lakhs
Okay,
or 5
okay.
lakhs should be variable like that. But it's not
Oh,
somewhere related to the package. It's lesser than the
right.
package.
Lesser than, yeah, exactly, sir, exactly. So I mean, technically we can visualize a bonus, depends on case to case basis how the data talks about, but most likely, if unless and until that's a company like maybe Microsoft or Google or whatever, where they equivalently do the same thing, right, if I talk about, but still that is a very rare case scenario where they get bonuses equivalent to the salary, if I talk about. So in that case, I would rather choose my bonus to be in the form of, let's say, let me just bonus, and let me go to do this. Let's say bonus. Oh, I am changing this guy to, let's say, maybe I'll stick to U integer of 16. So half of it, maybe that is a realizable amount, I believe, 2 to the power of, but okay, again, let's say the maximum amount of salary gets hiked is 60,000 maybe or whatever or bonus. So in a real time company where you don't have big salary scales, right? In that case, it will be probably 30,000, 10,000, 20,000, or maybe 50,000. So I think more or less we can assume that if I talk about. So uint 16. I'm just putting that so that I can still reduce my memory footprint. And you can see the final memory usage here becomes 177, comparing it to 228. It's really what you say. You saved almost like 1/4 of the memory in this case, right, sir? So I think more or less everyone agrees with the concept here. Obviously, case to case scenario, we can differ with our thoughts and processes, but an overall perspective, I'm just assuming that, right? So, but the whole point is, the more we understand the data, the better we become in terms of the analysis which we talk about. Everyone agrees with overall structure which we talked about, right? All, all, uh, all good for all of us.
Right, Saumya.
Perfect, sir. Perfect. And I'm very happy
Saumya, I
to
think
see the
you
help. Yeah, sir.
elaborated this point also, no? Like int 8 means like it is occupying like 1 byte. So 16 means
Huh,
2 byte,
exactly.
32 means like
Huh, huh, huh.
four
Yeah,
byte.
yes, sir.
Okay, so
Right, sir.
that is what
Exactly. Exactly.
the length of the memory.
Yeah, the length of the memory.
So
Yeah,
that
exactly. You
is
can
very
say.
clearly so clearly it can like understandable by everyone.
Right. Yeah, I'll do that maybe.
Mm,
I think that should be it. I would
mm.
say 1 byte of memory. Let me
For
say
16,
16. Yeah,
two
yeah,
byte.
2 bytes of, yeah, or if I talk about, right, sir. So this is what you wanted, right, sir? And in an
Yeah.
overall perspective, I'm showing.
Similar way, 32
Right.
it is 4 and
32. Exactly.
64 it is like 8 byte.
Exactly, sir.
That's
32
mm,
is 4 bytes and 64 becomes 8 bytes. Yeah. Bytes, I should say, yes. So hopefully this brings everything into perspective. Thank you so much, sir. Awesomely said. Yes. Or maybe memory used to store or whatever you can talk about. Perfectly said, as we discussed about. Awesome. Now, let's move forward. I hope we all had a fun learning session here. Now, another important aspect of what do you say, Pandas is its group by feature, where you basically group things together to do some kind of aggregation, right? So, in the context here, right? And before I go to that, maybe I'll talk about a little bit. Okay, let's have a one more interesting discussion. So, how many of us know that the NumPy has the random module within that, right? Every one of us are aware of it, right? I will say rand. What does this do? Anybody? If I write this, what does this do?
With just random value generation
Perfect, sir.
or
Exactly.
hmm, I think
Yeah,
it's
right, sir.
generate floating point number, na?
Exactly, sir. You're right. Just like you said, this rand functionality, if you look into, let's look into its document. I'll use Shift tab. You can see it says random values in a given shape. So if I talk about, right, I haven't used any shape, so it gives me a single random number. So you can see that it shows me here as, it shows the interval as this. Can anybody tell me what does this mean? What does this interval mean in the mathematical notation? Anyone like to elaborate?
Like 0 to
I
1,
think
but not 1, right?
Yeah, exactly. Yeah. So this bracket, just like Jay sir has mentioned, and yeah, Ankit Paji, I think you were about to say that, right, sir? Ankit Paji was
no,
also
that's
part
fine.
of it. Yeah. So when I say this bracket, this means inclusive, and these brackets mean exclusive. That means it can take the value as 0, but it can never take the value as 1. I hope everyone is clear with the concept behind. So this creates, what do you say? It takes or creates a random number within the range of 0 to 1, right? So every time I run this, you get a different set of random numbers, right? So the whole idea behind. Obviously, I also have this, right? I can use the shape. It says D0, D1, Dn. So I'll probably use the shape as, let's say, 3 cross 4, right? So it creates a random number. I mean, it creates a random matrix or random array containing 3 into 4, 12 random numbers, right? I hope everyone is clear with that. Nothing pretty specific. And the moment I run multiple number of times, it gives me random values, right? Now, my question is, are they really random, by the way? Are they really random? Is my question. So I think this talks about whatever, 3, 4, 2. That means 3, 4, 12 into 2, 24. So there should be 24 numbers, right? So now my question was, what do we think that are they truly? Let me make this. Oh, sorry. I want to increase this. Maybe. Yeah. So we have a lot of numbers here. So I took the shape as 3 cross 4 cross 4. I have a big array of numbers. So what do we think? Are they random numbers? I mean,
I think my point of view, yes, it is the random number between 0 to 1,
all of them are
which is
random numbers.
generating the
Okay?
floating value.
Perfectly said, sir. Yes, they are indeed random numbers. Yeah. So Ankit Pati, you want to say something?
Yeah, random
Yes.
random number, but not
Mhm.
generated randomly.
Exactly. Awesomely said, sir. These, I would like to use a term called as, these are all pseudo-random numbers. What you see here, they are all pseudo-random numbers. You see this because of the fact that, just like how sir has mentioned, right? If I talk about, right, you can check this out. If I talk about, it all depends, and that is why we generally use the term, the way it works internally. It is basically a random. It works with the principle of a random number generator. So now you are using the word generator here, right? So आप सभी ने वो देखा होगा, you guys have seen, right? Like, uh, uh, I mean, there's Kapil, right? From Comedy Nights with Kapil. How many of us see that, by the way? Anyone who see Comedy Nights?
Yeah, I
Yes.
used to.
Yeah. Awesome. Yeah. Okay. I think,
Some of
yeah.
the episode I used watch, but not now.
Not now. Yeah. Earlier,
There
sir, you
was a
might have.
Mr. Golati, I guess, initially.
Yeah. Yeah.
Uh,
Exactly, sir. Yeah.
he left, I guess.
Exactly. So when it comes to that, why I just recalled that the thing is, uh, Kapil, he's really good at mimicking different artists. So I mean, he can mimic anyone's voice. So I mean, there's Amitabh Bachchan, and you might have all seen mimicry artists, right? They can mimic the stuff, right? If I talk about like the way he speaks or the way he walks, that is called mimicry, right? So when the person is not Amitabh Bachchan, but still he's able to mimic Amitabh Bachchan. So same way, what you see here, it mimics randomness to to such an extent, just like how Raja sir mentioned, they are indeed looking like random numbers. If you look into these values, there are no patterns which you observe in between them, right? They are really looking like random numbers. But the fact is, you are using the word here as generator because you use something called as a seed. So there is a seed which is defined, right? So we might have seen many of the times, we might have seen it in machine learning, many times we have seen in the deep learning segment, right? There is seed initializer. If you initialize the seed with a particular value, like let's say 55, right? It takes that value and generates. So it is easy for reproduction. So meaning for anyone who is using that same system, right? So if I use seed, right, I would always get the same random number. What I mean by that, you see, let me run this. let me take np.random dot seed, and let me take any random seed value, initialize, let's say 12. I can take any integer, and now I run it. Okay. You see, I have a set of values here. Okay. I have a set of values here, right? Now, if you tally it, I'm going to put it forward for, for others to see into, right? If I talk about, right? So if you look into, I've shared an array, right? This array has been generated by using the seed value of 12. And with the random, I've taken the shape as 3, comma 4, comma 4. You can also, if you want, you can, what do you say, reproduce the same thing with, but take the same configuration, take the random seed value as 12, and take this particular function, and simultaneously you can check it out, and you can tally that the numbers which are generated. Would you can someone just run it on their system and share the set of numbers which you get from your system? Use this seed value as 12, and the same shape, I'm taking 3 cross 4 cross 4, just try it. You would see the same set of numbers in the context here, if I'm not wrong. Like, just check it out once. If some of us are interested, you'll see the same set of numbers for the context here. So all of a sudden, the thing which was really like random no longer seems to be random in the context there. But however, it is, perfect. If I talk about it, is perfected in such a way that you can't differentiate that it is following a pattern to it. But still, these are all pseudo random numbers which are getting generated. Anyone trying that? Are we trying this? With the random seed value? Just let me know if someone of us are trying, right? First take the random seed as 12, or maybe or something else, right? Let's see, have a look. Jay sir has shared his pics. Yeah, perfect. Perfect. We can actually tally this. Let me keep it to the left and keep this to the right. You can see the array of numbers which you can portray from here, right? So just like sir has also shared from there, right? So basically the idea behind, so let's see the last few numbers. You can see 0.373723. You can see the same structure of it, right? Awesome. Nicely done, sir. Perfect. Awesome. You can see that. Awesomely done, right? So we can see that, right? So the world of randomness is pretty amazing if you talk about it still. And that's what makes it very easy to reproduce, right? So if someone asks next time that can the machine learning algorithm always, because at the end everyone knows that ML or DL works on statistics, right? And if you have the same set of values, right, with, let's say, initialized with a particular seed value, then you won't wind up getting the same output if I talk about, right? So in the context which we are describing here, right? So I think more or less we understand the concept here. This is what I wanted to actually share, right? So the idea here is, it's what we see here. These are pseudo random numbers which are made to mimic randomness rather than actually being random in the context. There is no difference in the context there, right? And the way our systems are designed or the computers are designed, given the context, they are unable to actually create a real use case of random numbers. In case if you want that, then you introduce nature to help you with actual randomness. So you have to incorporate the natural scene of the data which you collect from the nature or the noise which you collect, all of those things, and then you mimic it here. So they have studied a lot of different patterns of noises, and then you talk about in the context of getting the random numbers, which looks like random. You can change it. Obviously, if you want, I can maybe, let's say I have this or a little bit bigger one, So you can see I'm having 3442 with the same maybe random seed value of 12. You can see that if you run the same code again, we'll find that the same numbers pop up this time as well. All clear for everyone, right? Is it clear for everyone? Understood? All of us,
Yeah,
right?
perfectly.
Perfect, sir. Perfect,
Yes.
perfect. Thank you so much. Awesome, sir.
Soumya,
Now,
one thing I wanted to
yeah,
clarify actually, maybe I missed it that point. So
no
you
worries.
here you are we are giving like seed 12. Okay.
Right, sir.
Like
Uh-huh.
for example, if you are not giving seed 12, then
Uh-huh.
which will
Let
generate the
me
random number, right?
let me run this, sir. I don't provide
Mm.
any seed. Let me run it
Okay.
again and again. I ran it, you
Mm.
see 0.47. Let me
Yeah,
run it
yeah.
again.
Means
Yeah,
again you're
yeah,
running means the
exactly.
value, random value will change. Okay.
Right, sir.
If you are
Right,
giving
sir.
that seed value,
Right, sir. If you give the seed value, it generates based on. So basically, it is like an index. So, sir, the seed is acting like a register, sir. You might have seen that page number 5 contains chapter 2.
yeah, yeah, yeah.
So,
Mm.
yeah. So when you initialize with 5, it goes to the chapter 2, and whatever set of random values are there, it produces that for you. So that's the whole point.
Sure.
Right.
Okay, sir.
Perfect, sir. Perfect. Perfect. Awesome. So now moving forward, now that we have understood the idea of seed, I wanted to introduce the idea of seed because next thing which you are seeing here, I have actually done that same thing. Now I think more or less we all understand that since I'm using the seed value of some random number, here I'm saying 512, I've just used a random number as 512. You can use 1000, 2000, whatever for easier reproducibility. So if I'm using this number and I have some few names, I try to incorporate our own trainers here, a set of few other names here, right? You have this stuff. So there's this category where I have the departments. You can see in the context here. Yeah, there is one more interesting thing I wanted to talk about, right? There is one more function like np.random dot choice. Have we heard about this function? This helps us to create a random array based on the choices which we give, right? So if you look into, if I use Shift Tab, you'll see a few of the options here. Number one, it says A, right? So A simply means if I talk about, right, what are the choices? So A is, I'll put, let's say, generate a random stuff, right? Suppose, let me take a use case, a small use case. Let's say I'm talking about the month of February, okay? And in the month of February, I have four different weather conditions. Let's say one is, let's say, sunny, maybe I'll say rainy, and maybe let's say cold weather, or maybe let's say एक और कोई बता दो. Anyone? Sunny, rainy, cold. One more. Anybody? Sunny, rainy, cold, and what else? Stormy or whatever. I am having these weather conditions, suppose, right? Now, comma, I've just randomly taken that. Next thing I'm going to give is size in this doc string. As you can see, it says size, right? So let me just go down here. Maybe I'll keep these for very easy reference, right? So size may, I'm just going to say the month I'm talking about February because the month of February has a well-oriented calendar. It contains 28 days, which can easily be said as 4 into 7, right? 7, 4, 28. So there are 7 days in a week. So very easy to do. The other months are pretty hectic, like 31 days, 30 days, and so on and so forth. This is very easy. So that's why I'm taking the size. Let's say I'm saying four, what do you say? Weeks, and each week containing 7 days. So 7 into 4, 28 days. So that's what I'm talking about. And let's say, okay, fine. Let's first create it. You can see that now we have created a nice array, which looks really cool enough, right? If you talk about, I'm taking random choices from sunny, rainy, cold, and stormy. You can see that the first date is rainy, probably the second date is cold, and this is maybe I can create a nice, what you say, data frame out of it. Maybe I'll convert this to a data frame. PD dot data frame. I want it in the form of a PD dot data frame. You saw this. Let me keep this here. It'll be easy for us to interpret. So this was random choice, which we have just taken. And PD dot data frame, I'm going to say, let's say I'm having a, what do you say, column choice. I'm giving column choice because I have each column as days. So the first column, let's say Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So I'll say Monday, Tuesday, PUES, or maybe Wednesday, Monday, Tuesday, Wednesday, Thursday, Friday. Okay, I have Friday, I have Saturday, and I have finally Sunday. If I talk about now, based on this, if I talk about, we have now created a nice, what do you say, calendar sort of thing, right? To show a nice data frame from the choices which we have given, like sunny, rainy, depending on the climate change on, let's say, the first day, second day, third day, and so forth, right? Just to give a simple, fun angle to it, right? So in this context, and instead of having 0, 1, 2, 3, I would rather say that I want these are called, like, I hope everyone understands that these are columns. So I name the columns. I want to now name the indices, right? So if I talk about, let me use shift tab, you'll see that there is index as well. So I'll put, let's say maybe I'll use index and within that, maybe I'll say week 1, let's say week 2, week 3, and maybe I'll say week 4. That's it. And this probably looks cool enough, right? If I talk about the data frame is that of the February month with week 1, Monday, Tuesday, Wednesday, and so forth. We just created a nice small data frame out of the entire choices which are given. So I'm talking about random dot choice, how to use that. And there is the size parameter. Additionally, the random dot choice has one more additional parameter. If I talk about, you can see A, there is size. And if I talk about, I would like to talk about the P, that is probability. Here, let me show you. I can use probability. By the way, one thing to be noted is sum of all probabilities should be equal to 1. Okay, so I hope everyone understands in this context here. As of now, you can see, I mean, almost like equal distributions of everything, right? Now I want to shift everything. Like, that the month of February is more cold than sunny, right? We know that, right? The month of February in across all over India generally is cold compared to sunny, right? If I talk about, so I would say I'll give the probability, I'll give lesser weightage to sunny. Maybe I'll say sunny has 10% weightage. Or maybe I'll say 20% weightage, right? Rainy, it's very unlikely that the month of February receives rain, right? So maybe I'll probably say 0.05, right? You should be very careful about the total, right? Now, cold, I am going to say that cold is really, what do you say? It should be cold climate, right? So if you look into, right, probably I'll probably say 0. Maybe 7 or something in those lines. And stormy, again, very rare chance that it will be stormy in the conditions. So are all 4 of them equal to 1? Is it correct, by the way? 0.2 plus 0.7 is 0.9. Then you have 0.05 plus 0.05, that is 0.1. Yeah, I think that should be good enough, right? So I hope. So I'm saying the most likely condition in the month of, what do you say, February. I'm talking about the month of February. So probably I'm saying that it should be cold around February, right? So I'm giving it more weightage here compared to other climatic conditions or whatever, XYZ. Now, if I run this, can you see this? The sudden change which you see here, you see all of a sudden cold has more weightage. Can you see this? You have many of the days which are cold, if I talk about, right? Whereas, I mean, Rare cases, you will see rainy and stormy, right? You see rainy in the entire month, you receive rain only once, if I talk about, right? So I think it's actually fun to work with these kind of choices, given those, right? Now you can think of many different use cases, right? So you're throwing a random die 100 times maybe, right? So obviously the outcomes of the die can only be 1 to 6. So you can put that here in the choice. And then based on that, if you want to make it biased, so you put that the number 6 comes has much more likely it is much more likely to happen than the others, right? If I talk about, is it understandable by everyone? Are we all cool enough to
Yes, yes.
get perfect, sir? Perfect, perfect. So I hope it all of these things make sense. I'll probably share this with all of us here. Maybe I will probably give this in the terms. Let me do this. Oh, where did I put enter? I probably put enter. Okay, I'll just do this. Whatever. So I think you can just copy and paste that up in case you want to have a look. And obviously, I want the same set of numbers. What should I do for reproducibility? I will initialize with np.random.seed for reproducible. Suppose this time I give some random number as 57, and you can see this gives me so and so. I mean, it gives me this. So if you want this exact same output, you can take the random seed value as 57. You can see sunny, rainy, cold. If I run it again, we'll always see the same thing. You can see sunny, rainy, cold, and so on and so forth, right? So you can always use the random seed value to initialize at the same state. All cool, everyone? Is it understandable to all of us? Easy, easy. Shall we move forward? Is it perfect?
So
Perfect.
one thing I
Yes,
just
yes.
wanted
Yeah,
to
yeah.
clear
Yes, sir.
here.
Yes, sir. Yes, sir. Please.
Instead of 57, can we take any another number? Or that would be good choice
Yeah,
of
yeah, yeah. Yes,
X.
sir. It just came to my mind. I'll probably take 517. Yeah, yes, sir. So I've taken 517. It gives me this. You can also take 517 or maybe any number. But sir, if you take 517, you are going to get exactly the same thing which I see here. So that's the whole point. So that is the whole idea of having the seed being initialized.
Okay, okay, got it. Thank you.
Perfect, perfect. No. So that's the whole point of seed. But obviously, in a real use case scenario, when we are working as a data scientist or maybe machine learning engineer, we never use seed. It is just to maintain reproducibility. We use seed to see that is the algorithm performing exactly the same in all the machines. That's the only thing. Because the moment you add seed, I think you can understand that the moment I add a seed, I am becoming very biased because हो सकता है कि इस seed value में you get a lot of cold, which is getting little bit more biased towards cold, right? That should not be the case, right? It should be always at random. Sampling at random is, I mean, that's why randomness has its own set of positive attributes, right? So that's why we try to take random sampling rather than sticking to the exact same thing, right? So more or less, that's the whole idea behind the fourth which we are talking. All good. Shall we move forward? Is it understandable? All. आगे बढ़े? Perfect, perfect. Thank you so much, sir. Yeah. So now, sir, now that we are fully equipped with whatever is coming next, we have a set of names here, right? So we have others, Aziz, we have Aditya, Ankit, and so forth. I just made up that stuff. I have randomly initialized the seed value so that it is easy for reproducibility for everyone's system. Then you have departments, so and so forth. I'm going to take, you saw earlier, right? I used np.random.choice. So all there are 30 people here. The names, there are 30 people here. So I'm going to shuffle this departments. I'm also going to shuffle the years. I'm also going to shuffle hostel option. I'm going to shuffle club, right? And there is scholarship, right? I have these things here and I'm building my data. You see roll number being the first one, if I talk about, and then I'm just having a set of things. You can see that same thing which we saw earlier, right? Random dot choice. And I have all of these things. I have initialized the site. Oh, there are not 30. I'm very sorry. There are 25 people. in the above list, right? So there are 25 people. So I'm taking the size as 25. So you can see there are few things which are part of it. I'm taking this random integer for physics scores, maybe from 50 to 100 with a size of 25 and so on and so forth. I'm just trying to incorporate. I've created a, what do you say, column called email, which is containing N, the name of the person, and it is, what do you say, concatenated with @edunetfoundation.org and so on and so forth, if I talk about it. And you can see, let me just quickly run this up. Looks cool enough. I mean, we have a nice data frame here. We have the set of details just to mimic the stuff which we were talking about. So scholarships and stuff, right? If I talk about it, see the data frame here. Now, here we wanted to talk about group by. So the group by clause helps us to group things together and get certain information which was not earlier available in the context there. So if I talk about, you can see student data frame dot group by. I'm using a column for grouping it together. So suppose I'm using the gender column, right? Now that I have created the group by, right? If I print this, let me show you. It will show me the group by object. So, or let me just grouped. I'll use grouped maybe. Yeah. So, and let me show you. The first thing which gets printed is this. So the object, the group by object is created, and using this object, I'm going to say the object, I'm going to use the grouped object. I'm applying it to the math score column. This is the math score column, right? And I want to see how math scores are performed, like how the mean is performing based on the gender. There are two genders, right? Female and male. You can see, oh, we have female students excelling in math scores, it seems, and versus males are a little bit following up in the context here, right? So in this context, you can see that it gives us a nice grouped structure. So the idea is first you use the data frame and the method is group by based on which column do you want to group. So I'm saying gender column, and that's why you have female and male. You can group it based on maybe scholarship, maybe club, maybe anything and everything, right? Whatever it seems like, right? Maybe I'll say, depending on the club, how they are performing, I can probably say that in the you can see, I just copied and pasted club. You can see drama club. Oh, they are really good at maths, it seems, right? So robotics club. Oh, following up, nice. We have sports club. People who are good at sports seems to be good at maths. It seems like that, right? Music and the people who don't do any activity. It seems that their mean scores are not so good enough, right? If I talk about so, just a random stuff which we are just looking into, right? Just a little bit of a use case scenario which we talked about, right? You see that we have grouped it based on that. Now, let's say the next thing, if I talk about, you see that, by the way, whenever you group, you use some kind of aggregation. This is an aggregation, right? Mean is an aggregation function, right? If I talk about, right? So in the context here also, right? I want to do that. Suppose the best thing about pandas, in fact, any function is if I don't want to keep it three liner, right? Let me use view and show line numbers. I don't want to keep it three liners. I want to club it together. I can do the same as well. You can see that just after doing the group by, I have used aggregation as well, .agg, right? If I talk about, right? So in the context there, let me go ahead and do that. The AGG function is a little more advanced. Why? Because you can use multiple aggregations. You can see that attendance percentage, which we are trying to calculate, the mean attendance, maximum attendance, and minimum attendance in the particular group based on the gender column. I'm trying to do it here, right? You can see very simple and straightforward. You have the data frame, the group by clause. I'm grouping it by the gender, right? If I talk about, then I'm using some kind of an aggregation and I'm defining the aggregation, let's say, to the attendance percentage, the people who attended the classes, right? So we have, let's say, me, I want to measure three different parameters within the attendance percentage, and whether I want to see how many projects, total projects have been done by these people. So if I run this, let's have a look. You can see, I mean, if I talk about, you can see the attendance percentage of males is more compared to females if I talk about in the context here. But and also you can see that the maximum attendance is 99, whereas the females tend to have minimum less. What do you say? Less minimum attendance. If I mean more minimum attendance or whatever, comparing with the both the structure. If I talk about and the total number of projects done, that's what we are trying to sum it up here. The females have done 26 versus males have done 42. If I talk about, by the way, that is a hypothetical scenario. Please don't take it. Otherwise, I'm just kidding around. It's just the context here, which we are discussing about based on the random. Again, thanks to the seed, we are getting this. If I change the seed, you get a different set of numbers if I talk about, right? So then we have this, right? I earlier you saw that I grouped it by using single column, right? But if I want to have multi-indexing, meaning multiple number of columns, if I talk about in the context, I can still do that. Like I want to do it by department as well as gender. That means I think you can understand where is department in this case. If you look into the name of the department is CE. Under CE, you'll have male and female. Similarly, under ECE, you will have male and female. Same way, mechanical engineering, you have male and female, and so forth, right? So that is what is exactly going to happen next if I run this. And obviously, I think you can understand I'm trying to look into the maths course and so forth. If you look into that, right, look at this, right? Just like how we have discussed, CE, female, and so forth, right? The what do you say? The scores are so and so forth, right? If I talk about in the context there, right? So I hope it's particularly easy to reference and understand what is going on, maths, physics, and English scores, if I talk about, right? And you can see the different sectors which come up in the context here, right? So my question is, right, can anybody tell me how can I get the number 84? How can I get the number 84? Anybody would like to try it? I want to fetch the number 80, sorry, 84.5 zeros. Yeah, sir.
No, in terms of what, like from the data frame we wanted to
Yeah,
fetch, or
exactly, sir. From this data frame, I want to fetch the number 84.5. How can I do that? What should I write so that I get 84.5?
வரல வரல. எனக்கு தெரியாதா தம்பின்றீங்க.
Anybody would like to say?
Multiple
I
filters.
think in I
Okay,
think
sir.
like filter or search where 84.5 like that.
Okay, sir. Okay. So,
I think it is in SQL, I think. A bit
yes,
of
sir.
confusion with the both.
Exactly. Yeah, exactly, sir. It's
Uh,
actually such straight here. I'll show it. And just like I think Jay also mentioned, I was hearing, Jay said multi-index, right? I think Jay, you were mentioning that, right? Were you saying that?
Yeah,
Yeah.
multiple filters
Right.
based on some conditions.
Yeah. Actually, yeah, sir. So let me just quickly do that. Suppose this is you see that the type is a data frame. So let me first store it. Let's say this is a temporary data frame. I'm going to store this value maybe and temp df, whatever. And you can see that I have this, right? This is a data frame. So now let's see how we can. So I asked the question that I want to fetch the number 84.5, right? You saw that we created it using the group by object of these two columns, right? We created it using group by object of these two columns, right? So in this case, also, if I talk about, let me just put these forward. Maybe I'll talk about 84.5 can be fetched. You can see that I've stored it in temp df. So I can write the name of the department is CSE. The gender is female. So I will say, right, dot, probably I can say LOC. I think more or less everyone now got the context here. So the first index becomes, it is a tuple here. Okay. The first index becomes CSE and female, right? If I talk about, so I say CSE and female, right? And my column becomes the math score. If I talk about in the context here, if I look into, now you can see that it is straightforward. If I talk about, right, the I have to use the multi-index way of retrieving it because I'm saying within this, I'm talking about the CSC female and containing, I mean, they have secured 84.5. So I'm giving that. Can anybody help me with how it can be done using ILOC? That same number, how can I get using ILOC? Would anybody like to try? What can I put?
First row.
Okay, sir.
First row will give me CSE,
Okay, sir. Uh-huh.
and then zeroth row for female, I guess.
Okay, okay. So actually, here's the thing. When you talk about even multi-indexing, Jay is, I mean, very close. So whenever we talk about multiple indexing, right, you can see that this can be considered as the zeroth row. But if I write CE female and CE male, this is also same way writing like this as well. So same way I can write CSE. I can write here as ECE and so forth if I talk about. So that is why this index becomes an entire row if I talk about, right? Same way if I talk about, I have this one as the first row. Same way this becomes the second row, third row, fourth row, fifth row, and so forth in the downward direction. So this becomes the zeroth row, first row. So my interest was I wanted for CSC female. So in that case, I will go through this. This becomes the second row. And obviously the indexing starts from zero also here as well, just like how you see it here. You have 0, 1, and 2. So that's why this becomes 2, comma 0 to fetch the overall structure behind the context which we are discussing here. So let's maybe look into it to talk about that. So it's very easy if you use iLock versus LOC. You have to write a lot in LOC in the context here. So
That
maybe
means
yeah
2
yes sir.
comma
Go
3,
ahead.
2 comma 0 for 84,
Huh. For 84 sir.
0, 1,
Sir,
2.
sir, this is index. These both of them are indices, sir. I think, sir, you are saying
That is
three
column
because you are saying,
index.
yeah, exactly. So
Department and
this
gender both are column
both
index.
right, exactly.
Yeah.
Because if I say, let me show it to you here, temp
Okay,
df dot columns. Let me do that. You will see this. Sorry, this is columns, and maybe temp in df dot index will give me. Can you see this, sir? Index itself is multi-index type. It says CE female, CE male. You remember, right? I use this exact
got.
same thing, right, sir?
Mm.
Understood. Perfect, perfect, perfect. So that's exactly what is happening here in this concept here as well. So you have names as department and gender. It is a multi-index. And for the columns, you have the other thing which we have is math score, physics score, and English score. So you just take the name of the row and then the name of the column to get the final answer. Is it understandable by all of
Good.
us? All of us?
Go to that part now that where we are doing indexing.
सर हाँ सर इधर अच्छा नीचे हाँ
Okay.
सर बताइए
There,
हाँ
yeah. Okay, acha,
हाँ
okay. Like in first
got it
square bracket, because it's
yeah
multi-index, that's why we are giving
ex
two values. Okay. In
exactly
second
sir
square bracket, it will be the number or the
yeah
row that we want.
right
So it would
exactly
be
sir exactly
third row, that
so
means
if
two.
two exactly if I talk about in the context there because I'm talking about math score that means so math score was the zeroth row right sorry zeroth column right so it goes to the math score there so that's why I've written 0 here. I hope that's clear right sir. Is it understandable? Okay, sorry.
Yes, yes, yes.
Perfect,
I
perfect,
just
perfect.
want to fetch 84, so just write two and run
Ah,
it.
exactly, exactly. So a small task, maybe. How can we fetch this number? 85.333. Let me reduce this a bit. Maybe using iLock. It will be easy. So iLock would be easy. So how would you fetch this number? Anybody? How can we fetch this number?
6
6
comma 2
index. Yeah.
0 1 2.
Perfect. So this is 0, 1, 2, 3, 4, 5, 6. Perfect. This becomes the row number, that is 6. And 0, 1, 2, that becomes 2. That's right. Exactly, sir. Awesomely said. Right. So I think more or less it's clear for everyone. So 6 comma 2 shall fetch me this number, that is 85.33. How do I do it using LOC? What should I write using LOC?
EE female and
Right.
comma English score.
Perfect, sir. Perfect. Awesomely said. Just like how all of us have mentioned. Very nicely said, sir. Exactly. That's what we are expecting here, either in the form of the LOC or in the form of however it works out in the एक तो मेरा ये बाहर भाग जाता है, I don't know. Sometimes this shits around. Yeah, so I have this, sir. So I think more or less we understand how this iLock versus the LOC works, both in the case of the multi-indexing versus the normal indexing, if I talk about. So now, sir, I'm creating. Everyone knows how to create a new column. So suppose I have a new column which I want to create called as total scores. I can create it by using, like, I'm adding all of these scores together, and then I'm doing this. Let's say I'm wanting to find who are the top students. You can see I can use the method called as sort values. I'm sorting the values via the column name called as the new column which is created called total scores. And I'm saying ascending false, meaning it will be giving me the top 5 students, right? So ascending equals to false. And let's say top 5 because I have head here. So let me run this. And it seems Ankit Paji is performing very well. So you can see scores 362 and so forth. We have Uma, Rishikesh, Vinay, Vikram, and so on and so forth, right? So in the context here, I hope that's particularly understandable by, uh, sir, this is a
Always Ankit is in
hypothetical
top.
thing. Yeah, sir. See,
Always.
even the seed value is biased. See, sir. No, sir, I was just kidding around. So that's the whole point. So we have the top 5 students here. And more or less, that's what I wanted to just discuss about, sir. You have the data frame. We have this, the concat, very straightforward notion, which we talk about, like one below the other. If I talk about, you can see the concatenation based on the context which we are talking about. I can also have an access parameter based on that. Do you want to concat below or do you want to concat vertically? So depending on the context, you can choose that. Now, a very important thing is merging and joining, if I talk about, right? So in the case of SQL, we have the what do you say, merge and stuff, right? So we are going to quickly talk about that and look into it. So, but for the case of merging, I hope everyone understands that there should be table 1 and there should be table 2. There is no merging without multiple tables unless and until you are doing something like a self join in the context, or in fact, if I talk about in the context of joining here, if I talk about, right? So let me elaborate a little bit further on the context here. I have table 1. I already have table 1, which is that table. I'm taking this. I created that table, right? I have roll number, name, gender, and so on and so forth. The student data frame becomes one of the tables. Now I'm creating one more table here. If you look into, let me go down. Where is it? Yeah. So that's why I'm just calling it as write data, because uh, the convention is we have a left table and the right table, and then we perform what do you say, joining based on the two criteria. So in this context, I have just mentioned a few things, right? So we have others, Aziz sir, Medni, and so on and so forth. A few of the emails which who have done what do you say, who have done internships, and also whether they are ready for placement, the number of certifications done, and so on and so forth. I have that. So let's say I just run it randomly in the context here. I have the email ID, internship status, placement readiness, and certification. So I think everyone understands that for merging purposes, right, there has to be a column which is common between the two tables. And this guy here, the column called email, is common for this table as well as for the table here, right? If I talk about, right, we have an email ID column here, right? If I talk about, right? So thanks to this email, we are going to now join these two together and do some of the small operations in the context there. I think very easy on the context here. The how parameter describes how do you want to join. What is the inner join? Anybody? Quickly, guys. We'll finish it off in, let's say, 2 more minutes. Start. Anybody? What does the inner join talk about?
It's kind of primary, like how we connect two tables based on some common columns.
Right, sir. Right, sir. So the common column name is email, right? Just like
Yes.
how we have described. Now I am using the inner join. What does this inner join do? Like, I mean, when I say inner join, what does this retrieve? Very perfectly said,
Like
sir.
common email ID is there.
Huh.
Columns.
Exactly. So I have the left table, which is my student data frame. I have the right table, which is also containing all of these things, right? So I'm first running the inner join. Let's see, inner merge. You can see Adarsh, Azizer, Medani, Neha, and Sneha are the 5 people who have both the, like, who are present in both the data. So if I talk about, you can see none of them are empty. You can see the common between the two tables are fetched using the inner join, right? So you can see the context. There are 5 people, and that's why there is something called as unknown one and unknown two. They are not part of it because they are not in the what do you say? I mean, these two emails are not part of the original table as well. For if I talk about, right? Now, left join. What does this do? Very quickly. Awesome. Awesomely said for inner join. What does the left join do? So we say all from the left, meaning all from the left table. What is my left table in this case? I'm putting the left table as student data frame and matching ones from the right table, right? So that's what the left, what do you say, a left join does, right? If I talk about, so let me run this quickly to show that up to you, right? So you can see others, Aziz. So you saw that these were also part of inner join. So that's why you will see internship status for them as filled up, right? But if you look into Aditya and let's say Ankit, in this context, you can see that they are filled with nan values, right? Because it is fetching all the values from the left table. There were 25, right? There were 25 values in the left table. So all have been fetched, but matching ones from the right are only there. The others are filled with not available or not a number. All of us clear about it? Easy enough to understand, pretty straightforward. So you are saying all from the left, but matching ones from the right. Rest apart from that, all of them are filled with none or they are not available, right? So perfect, perfect. So same way we have the right, what do you say, right merged. What does this do? What would this do? So basically just like the opposite of left, right? So in the context, all the values from the right, but matching ones from the left. So in this case, you saw earlier, I had this 7 email IDs, right? So on, the output will contain 7 email IDs, right? You can see, but you can see that these things are not fetched, right? Just like how you can see there, there's no roll number, no name, no gender for the NAN. I just randomly put in there. So I hope that's particularly clear. So I'm merging it towards the right if I talk about, right? So that's what we talk about. So the number of, what do you say, the length of this data frame will be exactly equal to how many entries are there in the right? So if I talk about in the context. And outer merged, if I talk about, outer will contain everything wherever there is. So you will see additionally. So there were 25 plus 2. Who are these two? There are unknown 1 at EduNet Foundation and unknown 2. These two will also be part of it. And that's why you will see 27 entries. You can see because the first index is 0. So all the way till 26. So 27 entries. All of us clear about it? Pretty Understandable to all of us? Yes? No? Maybe? All of us got it? Yes? Is it clear for all of us?
Yes.
Perfect, sir. Thank you so much. And finally, I'll just quickly like sort this out as well. There's the time series data. If we can even talk about Pandas to date time. So if you look into, you can see I'm taking the random dot choice or date range. So Pandas has a nice functionality called date underscore range. So you're taking the range of date from 1st of January 2000 to 31st of December 2005. So I'm taking this as DOB list. I'm just randomly putting that, right? So you're creating that. And I think you can understand if I don't convert this to date time, I won't be able to use date time functionality on it. Okay. So that is why it is important that we convert it to the type of the data becomes date time so that I can use more additional functions after that. What do I mean by additional function? You'll see shortly. So admission day list, there is the date range, so and so forth. You have a random dot choice, and obviously there are only two dates to choose from, right? So I think you can understand in the context here. Let me just quickly run it. And now let's see how the student data frame looks like, right? You can see there is the DOB column, right? You have the admission date column. There's one more date column which has been put forward. And let me say student data frame dot info. Why did I focus on converting it to date time is because of this small thing which I talk about. You can see that thanks to using pd.toDateTime, these two columns have now been converted into date time 64 precision to nanoseconds, if I talk about, right? So DOB as well as what do you say, admission date has been converted into this. Now, since these two columns are of this data type, I can directly use this column and use something like dot dt. Let me show you what I mean. Look at this. I have this, right? I have this column called DOB. You see that there is a functionality .dt. This .dt will not be applicable had you not used, what do you say? Let me, let me talk about that a little bit. Maybe I'll just remove this from here, right? I ran it. You can see. Let me run it. Okay. As of now, because I had already ran the entire thing, I have to rerun the entire thing. But as of now, let's not it's already date range because I'm using the PD functionality to talk about in the context here, but it is always good unless and until, like, suppose in your data you do not have it in the form of date, then you can always convert it into to date time, if I talk about in the context there, right? So it helps you in the context that it will become date time 64. Now that you have used that, you can use .dt and extract days. You can extract year, you can extract month, meaning .dt.month will help you extract the month. If it were a time, you can also extract time. All of those things very easily get extracted if you convert it into the date time format. But if you keep it in the object format, you will still be it will still be problematic in the context there, right? So you won't be able to have the full flexibility of it, right? So if I run this, you have the final things, so and so forth. I have you can see, right, the age of the person, how we did this, right? If you look into the age of the person is, I'm taking the today's date, subtracting it from the date of birth, and you can see I'm using this double slashes. What does this double slash do? Converts it into integer. As simple as that. And that's what is happening in this case, in the case of the age. I think more or less this is particularly clear for all of us. And people, if I want to see who have joined before or maybe before 2022, old students, I can check that out and stuff, right? Based on the context, it's pretty straightforward, filtering and stuff, right? Oh, there
Can
was
you
this
share
very,
us these things? I
yeah,
think
yeah,
already
sure, sir.
we're
Sure,
running
sir.
out of time,
Yeah, yeah.
so we can't
That's
have
it,
all
sir.
those things.
Today I will stop it here, sir. And yeah, sir. I mean, I always think like I'll finish it off with that day. This this is what
It's not
happens.
possible.
So, so, but anyway, sir. I am done for the day, and thanks for being a nice
I just
audience.
wanted to know
Yes,
that,
yeah, yes, sir.
yeah,
Yeah, sir.
thank you. Monday, will there be any KT session?
Monday, sir, there will be the final KT session, I think, from Aditya, sir.
Oh,
Yeah, so he will take
thank
the
you so much,
final KT
Soumya sir.
session. No, no
And please
problem, sir.
share this to
Yeah,
us
I
so
will.
that we can
I will.
through the
Yeah,
rest of
yes,
the
sir.
content.
Yeah, yes, sir. There is no more content, by the way. That's it. I kept it until this point.
No
I
issue.
had because, sir, yeah, more or less, many of us know about read CSV and post that. I focused on data frames to talk about because the idea is after CSV, you convert it to a data frame and then do the rest of the things. We have discussed what happens post that, but this is the overall structure which I wanted to describe this stuff. So I hope more. I will, but there was this very interesting thing. I wanted to pull up Excel to show this to you, but I probably will do it on Monday. There's a very interesting thing that pivot table. I'll elaborate it probably on Monday, and we'll look into that aspect maybe for 5 minutes. I hope that is 5 minutes. That's the whole point. Anyway, sir. So that's the whole point. And thank you for being such a wonderful audience. And I'm really sorry, 11 minutes more. I'm very sorry. And I know today is the weekend for
On
everyone.
a weekend, you made us wait till 10 minutes.
Sir, I'm so sorry. That's the whole point.
It was
Had it
really
not been about
insightful,
Just
no?
kidding, just kidding, kidding.
No, I think it's a really insightful the sessions we have. No, like we are
thank
teaching
you,
these
sir.
things for long, but